Hello learners, welcome to this topic on Introduction to Fire and Fire Protection System Part 2. A building fire emergency notification system consists of audible and visual alarm notification appliances that are horns and stoves installed within all common areas of building and manual alarm stations installed at every exit from every level. Manual fire detection and alarm system is part of an active fire protection system. This system is manual in operation. It consists of a manual call point and hooter cum strobe. The manual call point and hooters are connected through a cable and further to the fire alarm panel. The operation is very simple. When a human senses a fire emergency, he or she pushes or presses the manual call point. The latch signal will send to the fire alarm panel where it triggers the hooter cum strobe in that particular area of the people to evacuate. This type of system is normally recommended for almost all buildings since it facilitates the occupants to inform the co-occupants regarding the fire scenario. In a few cases, like a residential building above 15 meters but less than 45 meters, this is the only method of fire direction where the inmates or residents will observe the fire and activate manual call point or MCP to alert the occupants for evacuation. While automatic fire detection and alarm system are similar to that of manual fire detection and alarm system with a simple modification where fire or smoke is detected automatically using a specialized devices called detectors. The system components are a fire alarm panel, automatic fire or smoke detectors, manual call points, hooters, strobe, and so on. This type of system is generally installed in high-rise buildings, malls, theaters, exhibition halls, airports, electromechanical rooms where automatic fire detection is essential to alert and evacuate occupants in case of a fire emergency. The operation follows the following logic. The detector sends heat or smoke and sends a signal to the fire alarm panel. The panel analyzes the address of that particular detector and alerts the occupants in that zone or floor to evacuate first. It also sends a precautionary message to the adjacent compartment or floor to inform about the fire in the adjacent area. Apart from alerting occupants to evacuate, the intelligent system will initiate many other actions such as activation of smoke extraction fans, pressurization system, lift calls, PA systems automatically. We have seen several water-based firefighting systems. This is a gas-based fire suppression system where gas is specially designed to suppress fire in unique areas. The system components consist of cylinder or cylinder banks depending on how big the area is, manifold to collect and carry the gas, pilot cylinder to activate further cylinders, gas release panel to give command signal for activation, piping and nozzles for effective discharge of clean gas. Since clean gas does not leave any residue on the target, this system is much welcome in high valued equipments areas like server rooms, data centers, labs and high cost medical equipment rooms. One of the important active firefighting system or life safety system is the smoke extraction system. Although it does not douse any smoke or fire, the system helps to extract the smoke from outside so that occupants are not inhaling the toxic smoke and become unconscious. This also gives good visibility and tenability so that occupants can easily evacuate without being engulfed by smoke or fire. This is a prime life safety system at places where large people gather like malls, hospitals, airports and so on. Upon getting a signal that there is a smoke or fire in a building through automatic fire detectors, the fire alarm panel will initiate the smoke extraction system to start. The system will in turn open the corresponding dampers and extract the smoke and throw out the things in the building. The system will also have makeup air provisions so as the people in the affected area are still getting fresh air. In high ceiling areas like atria, This system will extract through a fan since smoke tends to accumulate at the top and hence be extracted directly. The pressurization is another important active firefighting or life safety system. The system consists of a pressurization fan, ducts that dumps air in a closed space like a lift shaft, corridors, staircases to maintain pressure slightly more than atmospheric pressure. Since the system is pressurized, it will prevent the smoke or fire to ingress into the pressurized area, thus making it safe for occupants to evacuate. This system is also preventing smoke or fire to pass through from one floor to another. Signage is part of the passive fire protection system since it remains operational during normal as well fire scenario. Safety signage is usually seen in building premises which can guide occupants to the nearest exit in case of emergency. These signs are very useful in the building where occupants are not familiar with building exits. For example, hotels, malls, hospitals where people spend a minimum of time to understand the building egress. These signs are illuminated with the UPS batteries or with the DG backup so that even in case of power failure, these emergency signs continue to glow. Especially in the case of smoke or fire scenario, the visibility tends to come down and these illuminated signs can guide occupants to the nearest exits. Apart from emergency exit signs, signage is also proposed for firefighting equipment such as fire extinguishers, fire hose reels, manual call points for easy identification. The fire stop system is also one of the most important elements of the passive firefighting system. As we build a building, it is almost impossible to have floors, walls without penetration because of the passage of MEP services. These openings pose a serious threat as it breaches compartmentation and has a high chance of smoke or fire going to the adjacent compartment of the floor. Therefore, once the service such as pipes, cable trays, ducts, conduits pass the fire compartment or cutout openings, they shall be properly sealed with the fire stop system. Now, this fire stop system may be a fire barrier mortar, fire sealant, indomescent coating depending on the application. Building strength depends on the strength of structural elements. When the building is in fire, the change of properties of mechanical strength of structural members decides the strength of the building. As we all know, the steel loses its mechanical strength, thus comprising on building strength, putting all occupants at risk rather than the affected floors or area. Therefore, structural fireproofing becomes an important aspect to withhold its strength. There are two methods available in the market to do structural fireproofing. Vermiculate looks like cement slurry but has adhesive and fire rating properties. Indomescent paint looks like a normal paint but has fire resisting properties. In the cases of the RCC beam slab system, the concrete cover itself will act as a fireproofing and hence the separate fireproofing method is not necessary. One of the unavoidable elements of today's modern building design is glazing. As it looks lucrative, it also comes with a ban. Nowadays, architects and energy engineers are adapting a glazing for both aesthetic and energy saving purposes. Many codes recommend glazing be fireproofed, meaning fire rated glazing, which means it shall not allow heat, smoke or fire and undergo mechanical damage for the prescribed time. This makes the fire rated glass very costly and hence a balance is struck on the adaptation of glazing. In India, the code allows the fire rated glazing can be replaced with a normal glazing provided a sprinkler system within 600 mm from glass. This ensures when the bulb breaks, the water is sprayed on the glass, thus providing heat resistance. A firewall or fire rated door is another important aspect of a passive firefighting system as it provides a fire resistance for the specified time. This is normally used to create a compartment and allows passage of occupants but not smoke or fire. The doors are self-closing type, thus preventing the leakage or passage of the smoke or fire into adjacent compartment. These fire-rated doors associated with fire-rated walls provided a horizontal evacuation strategy which is very helpful in the case of hospitals where it is difficult to evacuate entire occupants outside the building. These fire doors are normally provided at access to emergency exit staircases or passages into an adjacent compartment. These doors are normally closed and even automatically closed doors. Fire tenders or fire vehicle is the firefighting and rescue vehicles that have complex provisions, connections and so on to enable firefighters to fight the fire, evacuate people in case of distress in a building. The movement of this vehicle around the building is very important because its accessibility and maneuverability play a vital role in fighting a fire in all possible ways. The fire tender vehicle movement shall be taken as a primary movement to decide upon other traffic movements. The fire vehicle requires a clear width, clear height and turning radius in order to have its movement properly. NBC 2016 recommends that the width requirement of the road where fire tender movement is envisaged to be a minimum of 6 meters. The turning radius is measured along the outside perimeter of the road to be 9 meters in order to have maneuverability. The snorkel extends its base using a hydraulic platform to get stability during evacuation. Hence, the requirement of 6 meters is always justified. The height clearance of the vehicle is also specified where it needs to be 4.5 meters. In case of any architectural entrance to a building or campus, the same need to be comply with this requirement. Moreover, due to its heavy weight, roughly around 45 tons, the road and all structural elements that come under the fire tender movement shall be able to withstand the load of 45 tons. In special cases where the building is super high rise and has a stilt and a podium to accommodate car parking, the fire tender vehicle movement shall be such that the vertical face of the building for easy access from road level. This applies especially to the location of refugee areas. Moreover, as shown in the figure, there are buildings where we have a large podium have a stilt floor level. In some buildings of this feature, the fire tender movement is provided even at the podium level. This will enable for a easy evacuation. However, there are cases where the podium is not accessible by fire tender movement also. In that case, the building facade line or the tower facade line shall not be more than 11 meters away from the edge of the podium. This will enable firefighters to conduct a rescue operation. It is also to be noted that fire tender movement is always required all around the building. However, the code allows some relaxation wherein based on the built-up area, the fire tender access can vary from 50% to 75%. Hello learners, welcome to this topic on Introduction to Fire and Fire Protection System Part 1. One of the most important parts of an active fire suppression system is a fire water pumping system. It keeps the system always pressurized, meaning all systems associated with fire water pumps are ready to fight the fire as and when it occurs. An active firefighting system requires pressurized water for the operation of a fire hydrant, sprinklers and so on. The firefighting pump helps us to meet the required flow and pressure of water during the firefighting operation. It can also be referred to as the heart of the fire protection system. It pumps water and keeps the active system such as hydrant system, sprinkler system in pressurized condition. It also helps to meet the fire water demand both in terms of volumetric and pressurized way also. The various types of firefighting pumps used in the industry are horizontal centrifugal N-section pump, horizontal centrifugal split casing pump, where the casing of pump is split into two due to its sizes. Vertical turbine pumps, where the impeller is submerged into the water but the drive is kept above. Vertical inline pumps, where the mount is vertical. The following are the various categories for which fire pumps are used. They are hydrant system, sprinkler system, water curtain system. The hydrant system is one of the important parts of the active fire protection systems. These systems helps firefighters to fight fire when the fire across the incipient stage, such as growth stage and the decay stage. It is mainly because from the hydrant system, the large volume of water at a high pressure helps to douse the fire in a very easy manner. There are two categories of hydrant systems. They are internal and external system. Let us see the internal hydrant system. This system is normally provided at staircase landings or inside fire hose cabinets. The entire system consists of a hydrant wall, rolled hose, end couplings, branch pipe with nozzle. All the elements will be connected to each other for a seamless flow of water and fight fire. The following are the features of an internal fire hydrant. The hose is rolled and can be extended for 30 meters by connecting male and female instantaneous coupling. The hose is generally 15 meters long and two numbers of such hose will be kept in coupling so that it can be connected to each other so that a total of 30 meters can be covered. There are also hoses with 45 meters in length depending on hazard and usage. Water flow is around 900 lpm at 7 bar and hence require specialized training to handle this equipment. In India, it is recommended to have a minimum pressure of 3.5 bar which will sufficient to fight the fire. The nozzle is of short, long type depending on throw requirement as decided by the local fire authority. It can project water for a minimum throw of 6 meters. The fire hydrant riser is provided with a fire bucket inlet in case of failure of pumping. An external hydrant system is similar to an internal hydrant system. Is a set of hydrant wall usually placed at a 45 meter distance at the building periphery. This system is useful in fighting fire without entering the building, that is from outside, or to fight fire in the adjacent buildings. We will see the yard or external hydrant system. This system is normally provided at the building periphery at a distance of 2 meters to 15 meters from the building wall. The entire system consists of a hydrant wall, rolled hose, end couplings, branch pipe with the nozzle. All the elements will be connected to each other for a seamless flow of water to fight fire. The following are the features of external fire hydrant. The system is similar to the internal hydrant and consists of a hydrant wall, rolled hoses with the end coupling, branch pipe with nozzle. The hose is rolled and can be extended for 30 meters by connecting male and female instantaneous coupling. The hose is generally 15 meters long and two numbers of such hose will be kept in coupling so that it can be connected to each other so that a total of 30 meters can be covered. There are also hoses with 45 meters in length depending on hazard and usage. Water flow is around 900 lpm at 7 bar and hence require specialized training to handle this equipment. In India, it is recommended to have a minimum pressure of 3.5 bar which will sufficient to fight the fire. The nozzle is of short, long type depending on throw requirement as decided by the local fire authority. It can project water for a minimum throw of 6 meters. It is usual for firefighters to fight the fire from outside the building. An automatic sprinkler system is one of the most important active fire protection system. The system is automatic, which implies manual intervention is not required for operation. Because the system is automatic and can reach all nooks and corners, this system is mostly preferred in areas where supervision is not throughout the day. The system is operated using a temperature sensitive liquid inside a bulb or fusible link. When the temperature rises, the bulb breaks or fusible link collapses, thereby water coming out with the pressure. The pressurized water then strikes the deflector and spreads the protected area to douse the fire. Depending on the application, various types of sprinkler system are available for standard coverage, standard or quick response, ESFR, ELO, etc. A standard coverage sprinkler will cover an area of about 12 square meter, which generally used in basement parking, office spaces, malls, hospitals, airports, and so on. Water spray system, also known as deluge system, which employs deluge valve, piping, nozzles combined to fight fire in the unique situation like forming curtain, forming water mist, peripheral drencher, window or tank cooling, and so on. These systems are typically used in hazardous environments where fires may spread very quickly or where valuable equipment surrounding the fire needs to be cooled. Depending on the application, the system has various names. We'll see one by one. Water curtain system. This system typically used in basement car parking by providing water curtain to form compartment so that fire from one zone to another zone is arrested. Number 2, medium or high velocity water spray system, which is used around the large fuel tanks in fuel farms, transformers to cool the target. Number 3, high velocity system. It is often used to protect equipment that incorporates a heavy or medium oils equipment such as transformers, circuit breakers, diesel engines, fuel oil storage tanks, and oil fire boilers. Number 4, drencher system. For providing cooling effect to the glass facade, building structural glazing, airport airside glazing, and so on. Number 5, water mist system. As the name indicates, small droplets deliver high fire protection. Water mist is a versatile and highly efficient firefighting medium with a small droplet size. When a droplet of water vaporizes, it expands. Because heat absorption is a function of surface area and not volume, smaller droplets mean more surface area and therefore faster heat absorption. A medium and high velocity water spray system is a special system consists of fixed pipeline with a pressurized water network connected. This system also employs high or medium velocity water spray nozzles which spray water at a particular angle so that it covers the entire surface of the protected area. It can be transformer, diesel day tank or large fuel tanks and so on. The mechanism of actuation is through a detection link where air or water is filled and connected to sprinkler bulbs. If any of the bulbs break, the deluge valve open, the water will be discharged throughout the surface. A high velocity water spray system is used in the following areas: transformers and oil filled equipment of power stations, turbo alternators, oil-fired boiler rooms and oil quenching tanks, and cable walls. Medium velocity water spray system is used in the following areas: general area protection plants where flammable solvents are stored, horizontal storage vessel, for example LPG bullets and so on, vertical storage vessels, for example benzene, xylene, toluene tankage, spherical storage vessels, for example LPG bullets, spears and so on, and spot protection of selected areas or equipments. The foam or water monitor system is also one of the active fire protection system used for specific protection purposes like high-rise building, oil refineries and helipads. Foam type extinguishing agents are best for oil-based fires. These fire monitors are especially designed so that it delivers a huge amount of water and foam at desired pressure. It can be operated both manually and automatically. Foam monitors are accommodate foam tanks, inline inductors along pressurized water. The foam will be injected into the upstream piping to generate foam solution. It is designed such that these monitors are used from remote locations or high heights. The water curtain system is one of the active firefighting system which is gaining momentum in recent days, especially after NBC recommends using it for basement car parking. It is also part of the water space system designed to make fire compartments. As the name itself defines, it forms a curtain to prevent the spread of smoke or heat or flame from fire captured area to no fire area. By forming curtains, effective compartmentation is achieved, especially in large areas like basement car parking, etc. As per NBC 2016, this type of system is permitted for a basement car parking areas. The system consists of open nozzles, piping and a deluge valve network forming specific curtain patterns to prevent the passage of the fire from one compartment to the adjacent compartment. The system forms a curtain through a specially designed nozzle so that locating it in a series will form a water curtain throughout the compartment line. This is generally a dry type pipe system with open nozzle, and when the fire is detected through more than one detector or a sprinkler flow switch, the deluge valve gets activated, thereby discharging water to all the nozzles. Water mist fire protection system is yet another active fire suppression system designed uniquely for specialized areas like DG set room, server room, document storage area and so on. The system consists of the water storage tank, pressurizing pump, piping and specifically designed nozzle that deliver water mist, a very minute particle of water for cooling the atmosphere and the target. These minute droplets or mist are used to extinguish the fire by means of removal of heat and cooling the surrounding areas, thereby avoiding reignition. This system is classified into three types as per NFPA 750. They are low pressure, 12.1 bar or less, intermediate pressure between 12.1 bar to 34.5 bar, high pressure 34.5 bar or greater. Hope you all had a clear understanding with this topic. Thank you, learners. Hello learners, welcome to this topic on Introduction to Fire and Fire Protection System Part 1. Fire is defined as the rapid oxidation of a material that releases heat, light and various reaction products. We will take a look at one of the videos which demonstrate how a fire causes a massive damage to the life and property with time. Fire impacts people, property and the environment. In some fire incidents, the resulting losses are unexpected, causing death, widespread damage to property and building. Most fatalities from a fire accidents are not due to burns but a result of inhalation of toxic gases produced during the combustion. Fire produces a complex toxic environment involving flame, heat, oxygen depletion, smoke and toxic gases. Before proceeding further, let us see some of the statistics on fire. One civilian fire injury was reported every 29 minutes. One structure fire was reported every 62 seconds. A fire department responded a fire every 20 seconds. One civilian fire death occurred every 2 hours and 23 minutes. One home structure fire was reported every 83 seconds. One outside fire was reported every 39 seconds. One vehicle fire was reported every 109 seconds. Hence, it becomes increasingly important to understand the science behind the fire to avoid damages to the lives and property. We have seen the various elements responsible for the fire. One of the equally important aspects is fuel. The various classes of fire have been categorized based on the type of fuel. This classification or categorization helps to fight fire by application of the right type of extinguishing agent. We will discuss various types of extinguishing agents during the fire extinguishers topic. As we can see, the broad classification of fire includes class A, class B, class C, class D and class K. These classifications are not the same everywhere and slightly varies depends on the countries adopting different codes. Class A mainly deals with most common ordinary combustibles like wood, paper, cloth and so on. Class B mainly deals with flammable liquids such as grease oils, petrol, paints, solvents which are mostly hydrocarbons. Class C mainly deals with the electrical related fires such as electrical panels, wires, motor that are electrically energized. Class D mainly deals with combustible metals that normally don't burn but at extreme temperatures metal can ignite and cause a serious hazard. Class K mainly deals with commercial cooking equipment such as cooking oil, animal fats, vegetable oils which are significantly different from Class B as it involves edible substances. We have seen the various elements responsible for fire, its categories and how to prevent the contain it. All these are to be effectively implemented in the construction of buildings. It is also essential to categorize buildings to understand the usage, hazard risk, number of people to be occupied and so on. Accordingly, Group A corresponds to residential occupancy. Examples are dwelling units, apartment houses, hotels, hostels, quarters and so on. Group B corresponds to educational occupancy. Examples are schools, colleges, tuition, coaching centers and so on. Group C corresponds to the institutional occupancy. Examples are clinics, hospitals, prisons, mental asylums, etc. Group D corresponds to assembly occupancy. Examples are public spaces like temples, railway stations, airports, dining halls, convention centers, malls, theatres and exhibition halls, etc. Group E corresponds to business occupancy. For example, office spaces, government institutions, libraries, laboratories, data centers, telecommunication centers, etc. Group F corresponds to mercantile occupancy. Examples are retail outlets, shopping complexes, apparel centers, etc. Group G corresponds to industrial occupancy. Examples are industrial establishments, factories, etc. Group H corresponds to storage occupancy. For example, storage yards, godowns, multi-level car parking or MLCP, etc. Group J corresponds to hazardous occupancy. For example, explosive production or manufacturing units, LPG bottling plants, fuel or paint storage, etc. As we have seen the examples of various types of occupancy, some of the hazard with respect to a firefighting application is more or less the same. Similar hazard groups are further grouped into a fire zones. They are from Group A to Group E on it is categorized as fire zone 1 or a relatively low risk category. From group E2 to 5 to G1 to 2, it is categorized as fire zone 2 or relatively moderate risk category. From group G3, H to J, it is categorized as fire zone 3 or relatively high risk category. These fire zones are further linked into the type of construction. If the construction type is 1, the fire rating requirements of the wall, roof, columns and beams and other structural elements are relatively high, therefore giving more protection, and this fire rating requirement gradually reduces up to type 4 and it is less stringent. Since building occupancies in fire zone 1 are relatively low, there is permitted to go with any type of 1, 2, 3 or 4. In the case of fire zone 2, type 4 is not permitted, thereby type 1, 2 and 3 are permitted. In the case of fire zone 3, only type 1 and type 2 is permitted. Type of construction implies fire rating requirements of building elements such as exterior walls, fire check doors, fire enclosures of exits, columns, beams and floor-to-floor roof and so on. In the case of type 1 construction, the requirement is very high. 4 hours of fire-rated load-bearing exterior walls need to be constructed. The requirement will go down as we move towards type 2, type 3 and type 4. As we have seen, the permissibility of type of construction of various occupancies depend on fire zones and thereby their risk category. It is imperative that type 1 is more stringent and less vulnerable to fire scenario compared to the building in type 4 construction. Therefore, the vulnerability increases from type 1 to 4. There is one more factor called floor area ratio or FAR, which determines the permissible type of construction. As we can see from the formula, the FAR is the ratio of total coverage area of the all floors, assuming 10 floors, 10 into single floor area to plot area, which is available ground area upon which the building is constructed. Once we determine the FAR value, the table can be referred to as the occupancy classification. From the table, we can derive the type of construction that is permissible. For example, the permissible FAR value for residential building, if we go for type 1 construction, is UL or unlimited. Therefore, any height is permissible. If we go for type 2 construction, then FAR allowed is only 2, which means the built up area can be twice that of the plot area. Similarly, for type 3 and 4. Developments in the building construction field have introduced many more engineered composite structural techniques and elements, as well as the use of synthetic construction materials. The use of various materials impose fire risks in buildings that requires strict reviews before they are being used in the construction of building. Refer to the table in the slide. This is adapted from NBC 2016 of India, Part 4, which talks about the fire resistance rating of each type of building component. If we get into the detailed mention in the first table, we can see fire resistance rating requirements for structural and non-structural members of a building. A fire resistance rating typically means the duration for which a passive fire protection system can withstand a standard fire resistance test. The table covers most of the structural elements such as exterior walls, fire separation assemblies like fire doors, windows, curtains, fire closures of the exits, MEP services shafts, separation wall in case of tenant spaces, dwelling units, interior bearing walls, a wall which supports structural members, floors and roof construction. If we study the whole table, we can understand that the fire resistance rating requirement for type 1 construction is high compared to type 2 and so on. The fire resistance rating ranges from 60 minutes to 240 minutes, and in one case the requirement is 0, that is there is no need for fire resistance rating requirement. Let us learn about how fires can be extinguished using manual and automatic systems. In the olden days, firemen would take up the responsibility of quenching the fire at a site when called upon. Many developments in the field of active and passive fire protection systems are made and increasingly used in the multiple types of buildings. We will learn in brief about some of the following major systems used in the building to fight fire. They are fire extinguisher, fire water pumping system, internal and external air hydrant, automatic sprinkler system, water spray system, foam and water monitor system, water mist system, water curtain systems, manual and automatic fire detection system, gas-based fire suppression system. The simple yet convenient form of firefighting equipment is fire extinguisher. This equipment is one of the active fire protection system as it comes into the operation when there is a fire. It helps to douse the fire at a very incipient stage. Remember stage 1 initiation of fire curve. According to various classes of fire, type of fuel, various types of fire extinguishers are available in the market. Commonly used fire extinguishers are ABC type fire extinguishers, water type, carbon dioxide type, foam type, clean agent type and so on. An applicability matrix is provided on which types of extinguishers are best suited for which class of fire. They are class A fires, water type, foam type, ABC dry powder and halogen type. Class B fires, foam, ABC type dry powder, clean agent and carbon dioxide type. Class C fire, ABC type dry powder, clean agent and carbon dioxide type. Class D fire, extinguishers with special dry powder of metal fires. Class K fires, extinguishers with a special extinguishing agent for kitchen fires.
Welcome to this topic on fire codes and standards. At the end of this topic, you should be able to describe the fire codes and standards, explain the local fire jurisdiction. Let us look at how life safety design is adopted in a building or a premise. There are two approaches to life safety design. They are prescriptive approach, performance-based approach. In India, we mostly follow prescriptive design, which is based on National Building Code or NBC and other local building bylaws. So the content of this module will be primarily based on NBC 2016 edition. In the case of a typical building, the codes or standards already specify the requirement for them. Hence, the code-based prescription is adopted in those designs. Let us see some of the widely used fire codes and regulations. Fire codes are guidelines that the designer may use as a minimum reference in designing a system. Some of the commonly used fire codes in India are National Building Code of India, Bureau of Indian Standards, British Standards, European Standards, ASTM Standards. The code was first published in 1970 at the instance of the Planning Commission and the first revision came in 1983. Thereafter, three major amendments were issued to the 1983 version, two in 1987 and the third in 1997. The second revision of the code was in 2005, to which two amendments were issued in 2015. The latest version of NBC is NBC 2016. The code is a very comprehensive building code and is being applied nationwide and has become a common regulating guideline for construction activities across India. It is widely referred to and used by all stakeholders of the construction industry, including local statutory bodies. Bureau of Indian Standards or BIS is the national standard body of India established under the BIS Act 2016 for the harmonious development of the activities of standardization, marking and quality certification of goods and for matters connected therewith or incidental thereto. BIS has been providing traceability and tangibility benefits to the national economy in several ways. They are providing safe, reliable quality goods, minimizing health hazards to consumers, promoting exports and imports substitute, controlling over the proliferation of varieties, and so on. Various Indian standards have been used for the design, installation, and maintenance of firefighting detection and alarm system. Similar to NBC and IS in India, other countries and bodies also have regulations on basic and advanced systems. Those codes sometimes are stringent and sometimes are less stringent. But when a code is applied, it needs to comply uniformly. Part compliance is not a good practice. Some of the internationally recognized fire codes and regulations are National Fire Protection Association or NFPA based out of USA. The NFPA codes are vast, extensive, and tested frequently, and hence, many countries where they don't have a code for a specific application, NFPA will be adopted. Similar to NFPA, British Standards also has a variety of codes for many product-based applications. This code is also extensively used in the Middle East and African countries. European standards where all European Union countries contribute and develop code and followed across Europe. American Society of Testing and Materials or ASTM develops and publishes consensus standards and is one of the world's largest international standards developing organization. The local development authority of the city will have overall control over its permissibility and construction oriented regulations. Some of the local development authorities of major Indian cities are Delhi, Delhi Development Authority or DDA, Mumbai Metropolitan Region Development Authority or MMRDA, Chennai Metropolitan Development Authority or CMDA, Kolkata Metropolitan Development Authority or KMDA, Bangalore Development Authority or BDA, Hyderabad Metropolitan Development Authority or HMDA, and Hyderabad Urban Development Authority or HUDA. According to local geography, the Development Authority entitles to have its recommendations and guidelines. The building which is under these jurisdictions shall follow the local development guidelines or codes to get a building permit and approval for occupancy. Within the local municipality jurisdiction, the fire department is also part of it, where it may or may not have its guidelines. Some of the local fire department follows NBC or adopt the local development authority guidelines. The local fire jurisdiction, also known as the authority having jurisdiction, will require the builder to submit plans of the proposed construction building and have rights to alter the plans. The authority may also propose some additional safety measures on a case-to-case basis. Once the building is completed, the local fire authority shall be called for visual inspection. The fire authority will cross-check with the drawings submitted and the recommendations provided by him during the planning stage. Upon compliance in all aspects, the fire authority issues no objection certificate, which will further enable the building to obtain an occupancy certificate. Once the building is constructed and all fire and life safety systems are commissioned, the fire authority will be called for inspection. The fire authority visits the site and inspects many scenarios of fire and verifies the activation of firefighting and life safety systems. If found satisfactory, the fire authority issues NOC, and if not satisfactory, some more recommendations will be issued and need to be adhered. The cycle continues until found satisfactory. The NOC issued is a prerequisite document for obtaining an occupancy certificate. This NOC shall be renewed each year or as per the cycle mentioned by the fire authority. Let us summarize all that you have learnt. Fire codes are guidelines that the designer may use as a minimum reference in designing a system. BIS is the national standard body of India established under the BIS Act 2016. The local development authority of the city will have overall control over its permissibility and construction-oriented regulations. Hello, welcome to this topic on Basics of Life Safety Systems. Shown here are the images of the internal staircase and external staircase. Irrespective of the type of staircase, some need to be provided mandatorily. They are: it shall be constructed of non-combustible materials with a fire resistance rating of 2 hours. Handrails shall be provided. Staircases shall be continuous from ground to refuge or terrace floor. No electrical shafts or air conditioning ducts or gas pipes and so on shall pass through or open in the staircases. It shall be kept in sound and usable condition at all times. In a few cases, the staircase is merged with fire lift and fire hose equipment and together called a fire tower. Fire tower used in the Fire and Life Safety Code of NBC consists of the staircase, fireman's lift, fire hose shaft. Space shall also consist of the evacuation floor plan and fireman's talkback system. This fire tower arrangement will be easy for firefighters for evacuation, communication, and handling other rescue operations. One fire tower shall be planned for each residential building or educational building. For other occupancy types, the requirement of a firefighting shaft shall be ascertained in consultation with the local fire authority. As we have seen exist as one of the components of means of egress, the basement exit is one new strategy whereby we separate occupants from below exit level and above exit level. In the case of staircases, once occupants go inside the exit, it is assumed that the occupants are in relative safety. In the case of basements, due to their nature of occupancy, mostly used for parking, storage, and electromechanical plant rooms, shall have at least 2 distinct exits. These exits shall be independent and shall be able to suffice the capacity to exit the calculated maximum permissible occupants. Basements having incidental occupancies to the main occupancy shall be planned with exit requirements of the basements for the actual occupancy within the basement. Where basement is used for car parking and also there is a direct approach from any occupancy above the basement, door openings leading to the basement shall need to be protected with fire doors with 120 minutes fire rating except for exit discharge doors from the basements. Fire compartmentalization is a strategy to compartmentalize the fire or smoke and thereby contain it to avoid further spread or damage. Since in all buildings the hazard is inevitable, NBC recommends dividing each floor into at least 2 compartments to arrest the spread of smoke or fire. Accordingly, each floor above 750 square meter to be divided into at least 2 compartments, and based on the type of occupancy and its usage, the area limitation of each compartmentalization is provided. The fire compartmentalization shall be capable of holding smoke and fire for a minimum period of 2 hours. The way to achieve fire compartmentalization is through a fire-rated wall or door or fire curtain. In the case of the basement used for car parking, a water curtain is used as a method of fire compartmentalization. The term refuge area implies it as an area of refuge in case of distress or emergency in the building. It shall be provided in buildings of a height of more than 24 meters. The refuge area provided shall be planned to accommodate the occupants of 2 consecutive floors by considering the area of 0.3 square meter per person for the calculated number of occupants and shall include additionally to accommodate 1 wheelchair space of an area of 0.9 square meter for every 200 occupants. The refuge area shall be provided on the periphery of the floor and open to air at least on one side protected with suitable railings. The refuge area shall be fully sprinklered and shall connect directly to the fire tower. A fire command center is a dedicated room or a space in which the fire alarm panel or fireman interface units are placed. Some of the guidelines in situating and providing a fire command center in a building are: the fire command center shall be on the entrance floor of the building having direct access. Direct access means the fire brigade or fireman is not required to enter the building to gain access to the fire control room. The control room shall have the main fire alarm panel with a suitable public address system to aid floors and facilities for receiving messages from different floors. Monitoring of integrated building management systems, CCTVs, or any other critical parameters in the building may also be from the same room. Details of all floor plans along with details of firefighting equipment and installations shall be maintained in the Fire Command Center. Let us summarize all that you have learned. Life safety in buildings can be divided into life safety systems and life safety features. Pressurization is a method adopted for protecting the exit from the ingress of smoke, especially in high-rise buildings. A fire command center is a dedicated room in which the fire alarm panel or fireman interface units are placed. Hello, welcome to this topic on Basics of Life Safety Systems. At the end of this topic, you should be able to describe the life safety system, explain the life safety feature. The life safety system on buildings has become essential and more important as many of the modern day buildings are unique in architectural style. Therefore, it is essential and mandatory to strategize a life safety system in buildings. The system consists of various important subsets such as means of egress, fire tower, occupant load, travel distance, and so on. Life safety in buildings can be further divided into life safety systems and life safety features. These are made up of elements that are designed to protect a building and its occupants during a fire or emergency. An integrated and fully functioning life safety system can improve the safety of a building. The life safety system includes a smoke exhaust system, stair pressurization, emergency elimination system, and fire stop, which will operate during a building fire to minimize the loss of lives and help to provide a smooth evacuation of people. Let us now look at the life safety system in detail. It is generally provided in large lobbies or atriums where fire or smoke tends to go up and start accumulating. The system focuses on the removal of smoke from the occupied floor and allows fresh air to come in, so that the occupant can evacuate the building without asphyxiation or untenable condition. The smoke exhaust system includes an exhaust fan and ductwork. At the time of smoke, the air handling fan is shut off and the air damper is closed. The smoke removal fan runs at a constant speed to move the smoke to outside along with the smoke fan damper open. The pressurization is a method adopted for protecting the exit from the ingress of smoke, especially in high-rise buildings. In pressurization, the air is injected into the staircases and lobbies to raise their pressure slightly above the pressure in adjacent parts of the building. As a result, the ingress of smoke or toxic gases into the exits will be prevented. The pressure difference for staircases shall be 50 pascals and for lobbies shall be between 25 pascals and 30 pascals. Further, the pressure differential for the enclosed staircase adjacent to such lobby shall be 50 pascals. For enclosed staircases adjacent to the non-pressurized lobby, the pressure differential shall be 50 pascals. This system is generally provided in enclosed or internal staircases used for fire exit purposes. This system enables a pressurization fan and injects air into the staircase so that the volume of the staircase is always pressurized, keeping the smoke or fire away from entering the staircase. A staircase pressurization smoke control employs techniques such as single injection supply system and multiple injection supply system, where the fan is located either at the top or bottom of the staircase. As the name suggests, The single pressurization system supply air at one location to the staircase. Even though the strategy is simple, the single injection system can fail if a few staircase access doors are opened near the injection point. To overcome this problem, a multiple injection supply system is used where the air is supplied at multiple locations over the height of the staircase. This system is based on the provisions of lighting with minimum illumination to ensure ease of evacuation. During a fire or smoke condition, the smoke developed is thick and black, which reduces the visibility of occupants, and hence this illumination will help in identifying the escape route out of the building. This emergency illumination system may include lighting along escape corridors, staircases, and all other egress components, exit signage lightings, wayfinding signage lighting, and so on. This lighting shall be UPS powered to reduce its dependability on raw power and continue to operate even during failure of the primary power supply. Buildings are equipped with a variety of features that are designed to detect the fire and to stop the spread of fire. Fire safety features in a building include parameters like stair width, headroom, fire rating, fire compartmentation, and so on, which adds to fire resistance of a building and timely evacuation of people with minimum casualties. Now we will look at the life safety features in detail. The term egress refers to a path to safety. It can be horizontal or vertical and shall be continuous and unobstructed. It is always referred to as a path from any occupied portion of a building to a safe exit, which can be a portion of the same building, adjacent building, streetway, or outside the building. According to its distinct functionality, the means of egress has been further divided into three types. They are exit access. It refers to a pathway that leads to an exit. It can be a protected or unprotected corridor, walkways, aisles, and so on. Exit discharge, the element where the final discharge of occupants shall occur from the occupied building. This may lead to public streets, passageways. This element of means of egress is also called the ultimate safety point. Exit. It connects both exit access and exit discharge. This intermediate medium is very important because once the occupants enter the exit, it is presumed that they are relatively safe from the hazard. The exits are generally constructed from non-combustible materials. The term occupant load is the ratio between the area of the floor to the occupants. This term helps to determine the permissible number of occupants in the building. Since the occupant load factor is generally governed by codes and standards for various occupancies, the number of permissible occupants is the primary value in which all life safety systems will be decided accordingly. The occupant loads are prescribed in three ways. They are dense for highly occupied public spaces like assembly occupancy such as malls, theatres, auditoriums, and so on. Relatively less dense on mercantile and educational buildings such as schools, colleges, shopping complexes. Less dense in storage occupancies like godowns, storage yards, and so on. Capacity factor in means of egress refers to the number of people who can be discharged for the given width. It can also be inferred as the width per person in the occupied building required to exit. The capacity factor has two components. One is vertical component such as stairways and another one is horizontal or level components such as ramps, corridors, and doors. This width factor changes based on occupancies. Shown here is the capacity factor as per NBC 2016 Part 4. In the case of vertical component, the factor is 10 mm per person for assembly, business, mercantile, and industrial occupancies, which is relatively lesser compared to hazardous occupancy where it is 18 mm per person. In the case of horizontal component, the factor is 6.5 mm per person for residential, educational, assembly, business, mercantile, and industrial occupancies, which is relatively less compared to institutional occupancy where it is 13 mm per person. One of the other important aspects of means of egress is travel distance, which is the maximum distance from any point in the occupied space to reach a point where it is relatively safe. It can be a protected corridor, staircase, or external escape route. The length would be measured along the path of travel considering all hindrances in the occupied space. Shown here is the travel distance as per the NBC 2016. In general, the travel distance of residential, educational, institutional, assembly, business, mercantile, and storage occupancies are 30 meters. Industrial G3 and hazardous are 22.5 meters and industrial G1 and G2 are 45 meters. The dead end means there is no access beyond it. In the normal scenario, it may not sound harmful. However, in the case of smoke or fire scenario, the visibility and tenability get poor and the occupants must find the nearest exit path and escape out of the building. Therefore, it is important to restrict the dead end of the corridor to avoid occupants accidentally going into it and finally realizing that there is no exit and coming back to point of safety. It not only takes more distance to be covered by the occupants while exiting, but also increases the evacuation time. Since evacuation time is key in saving many lives, hence this aspect of the dead end of the corridor is very important and hence need to be carefully designed. The codes and standards restrict the maximum dead end of the corridor for educational, institutional and assembly occupancies are just 6 meters, whereas for other occupancies the same will be 15 meters. Hello, welcome to this topic on Introduction to Fire Protection Systems. At the end of this topic, you should be able to describe the active fire protection system, describe the passive fire protection system. As we have covered some of the basics of fire, its growth and its types, let us understand better about active and passive fire protection systems. Active fire protection systems are part of fire protection systems that comes into operation either manually or automatically when there is an event of smoke or fire. In a normal scenario, these active firefighting system does not perform any function but remains ready for quick action. As soon as the smoke or fire scenario emerges, the system will be activated for fighting the fire. Let us see some of the active fire protection systems used in building. The simple yet convenient form of firefighting equipment is a fire extinguisher. The equipment is one of the active fire protection systems as it comes into operation when there is a fire. It helps in dousing the fire at a very incipient stage. One of the most important parts of an active fire suppression system is the fire water pumping system. It keeps the system pressurized at all times, meaning all systems associated with fire water pumps are ready to fight a fire as and when it occurs. This system is useful in fighting fire within the building or from outside of the building. An automatic sprinkler system is one of the most important active fire protection systems. The system is automatic, which implies manual intervention is not required for operation. It can reach all nooks and corners, and this system is mostly preferred in areas where supervision is not possible throughout the day. Water spray system, also known as deluge system, employs deluge valve, piping and nozzles combined to fight fire in unique situations like forming water curtain, forming water mist, peripheral drencher, window or tank cooling, and so on. The water curtain system is one of the active firefighting systems which is gaining momentum in recent days, especially after NBC recommended using it for basement car parking. It is also part of a water spray system designed to make fire compartments. The foam or water monitor system is also one of the active fire protection systems used for specific protection purposes like high-rise buildings, oil refineries, and helipads. Water mist fire protection system is yet another active fire suppression system designed uniquely for specialized areas like diesel generator set rooms, server rooms, document storage area, and so on. This is a gas-based fire suppression system where a gas is used to suppress fire in unique areas. One of the most important firefighting systems is the smoke extraction and pressurization system. Smoke extraction. Although it doesn't douse any smoke or fire, the system helps to extract the smoke so that occupants are not inhaling those toxic smoke and become unconscious. Pressurization system. This is a prime life safety system at places where large people gather like malls, hospitals, airports, and so on. Since the system is pressurized, it will prevent the smoke or fire to ingress into the pressurized area, thus make it safe for occupants to evacuate. Fire detection and alarm systems are of two types. They are manual fire alarm systems and automatic fire alarm systems. Manual fire detection and alarm system is part of the active fire detection system. It consists of a manual call point and hooter cum strobe. The automatic fire detection and alarm system is a life safety system designed mainly to detect fires at an early stage and warn occupants. Fire alarm systems are also used to automatically trigger fire suppression systems like spray systems, water mist systems, gas fire extinguishing systems, etc. Passive fire protection systems are part of fire protection systems that remain in operation either manually or automatically even when there is a fire or not. In all scenarios, these passive firefighting system remains functional and ready for action. Let us see some of the passive fire protection systems used in building. Signage remains operational during normal as well as fire scenario. Safety signage is usually seen in building premises which can guide occupants to the nearest exit in case of an emergency. These signs are very useful in the building where occupants are not familiar with building exits and spend a minimum amount of time to understand the building egress. Some of the examples are hotels, malls, hospitals. The fire stop system is also one of the most important elements of the passive firefighting system. As we build a building, it is almost impossible to have floors, walls without penetrations because of the passage of MEP services. These openings pose a serious threat as it breaches compartmentation and has a high chance of smoke or fire going to the adjacent compartment of the floor. Therefore, once the services, be it pipes, cable trays, ducts, conduits, and so on, pass the fire compartment or cutout openings, they shall be properly sealed with a fire stop system. Building strength depends on the strength of structural elements. When the building is in fire, the change of properties of mechanical strength of structural members decide the strength of the building. As we all know, the steel loses its mechanical strength, thus compromising on building strength, putting all occupants at risk rather than the affected floors or area. Therefore, structural fireproofing becomes an important aspect to withhold its strength. Many codes recommend glazing to be fireproof, which means it shall not allow heat, smoke, or fire and undergo mechanical damage for the prescribed time. This makes the fire-rated glass very costly and hence a balance is derived from the adoption of glazing. A firewall or fire-rated door is another important aspect of a passive firefighting system as it provides fire resistance for the specified time. The doors are self-closing type, thus preventing the leakage or passage of smoke or fire into the adjacent compartments. These fire-rated doors associated with fire-rated walls provide a horizontal evacuation strategy which is very helpful in the case of hospitals where it is difficult to evacuate entire occupants outside the building. Let us summarize all that you have learned. An automatic sprinkler system is one of the most important active fire protection systems. Building strength depends on the strength of structural elements. A firewall or fire-rated door is an important aspect of a passive firefighting system. Welcome to the course on Fire and Life Safety in Infrastructure. At the end of this topic, you should be able to describe the basics of fire, explain the stages and classes of fire. Let us learn about the most important aspect of fire, that is the fire tetrahedron. The fire triangle is often spoken about in chemistry and firefighting studies. The three major components of a sustained fire are fuel, oxygen, and heat. While fuel supplies the raw material for starting and continuous supply for something to burn, oxygen is very essential for sustaining it. But it is not enough if only fuel and oxygen are available. Without sufficient heat, the process cannot be initiated. So, fuel, oxygen, and heat in the right combination are very much essential for fire to start. While these elements are responsible for the start of a fire, it is believed that removing one of the elements or varying the proportions will eliminate the fire. There is one more element called chain reaction, or the free radicals coming out of the combustion process is also required for sustaining the chemical reaction. Therefore, stopping or arresting these free radicals will break the chain reaction and stop the fire. Let us take a look at the fire stage curve, where the fire intensity varies with time. There are total of 4 stages: initiation, growth, steady, and decay. Smoke or fire gets initiated in this stage. This is where most of the primary fire or smoke detection or aspiration, protection, and fire suppression systems or extinguishers are focused on. It is easy to extinguish the fire at this stage. The fire grows by consuming more fuel. The fire is still manageable and can be controlled with the right methodology. In this stage, the fire grows exponentially. The fire has engulfed the entire fuel or raw material, and therefore it is beyond control. All the combustible materials are exhausted and no further fuel to propagate fire, and hence proceed towards decay and dousing. The various classes of fire have been categorized based on the type of fuel. The broad classification of fire includes classes A, B, C, D, and K. This classification helps to fight fire by application of the right type of extinguishing agent. These classifications are not the same everywhere and slightly vary depending on countries adopting different codes. Class A mainly deals with most common ordinary combustibles like wood, paper, cloth, and so on. Class B mainly deals with flammable liquids such as grease oils, petrol, paints, solvents, which are mostly hydrocarbons. Class C mainly deals with electrical related fire such as an electrical panel, wire, motor that are electrically energized. Class D mainly deals with combustible metals that normally don't burn, but at extreme temperatures, metal can ignite and cause a serious hazard. Class K mainly deals with commercial cooking equipment such as cooking oil, animal fats, vegetable oil, which are slightly different from Class B as it involves edible substances. Before fighting the fire, it is natural that fire shall be prevented and equal focus shall be attributed to this aspect. The modern building house has many combustible and hazardous materials which put occupants at high risk. To prevent fire, the 3 techniques are adopted throughout the world. They are prevention of formation of fire, resist the propagation of fire, restrict the growth of fire. In this technique, the formation of fire itself is prevented by using non-combustible or fire retardant materials. This can also be done by restricting high hazard materials or components in the building. Since the usage of non-combustible materials is not always feasible due to extensive usage of commonly available materials and cost implications, it cannot be avoided. Therefore, when the fire starts, we need to restrict its propagation by compartmentalizing and avoiding the spread to adjacent areas. In this technique, the growth of fire shall be restricted by good maintenance practices such as good housekeeping, following the 5S methodology, storage protocol, and so on. Let us summarize all that you have learnt. The 3 major components of sustained fire are fuel, oxygen, and heat. Class A mainly deals with most common ordinary combustibles like wood, paper, cloth, and so on. The growth of fire shall be restricted by good maintenance practices such as good housekeeping.
Hello learner, welcome to the course on Fire Life Safety Systems. In this comprehensive guide, we delve into the critical aspects of safeguarding lives and properties against devastating impact of fires. Fire, a rapid oxidation process releasing heat, light and reactive substances, poses a constant threat. Its repercussions extend beyond burns, often leading to fatal inhalation of toxic gases. Understanding its nature and dynamics is pivotal in preventing its catastrophic outcomes. This course explores the intricate details, starting with fire classes, categorizing fires based on fuel types. Building occupancy categories and fire zone classifications play a vital role in mitigating risks. Types of construction dictate stringent fire rating requisites. Material selection in construction requires meticulous review as different materials bring varying fire risks. The National Building Code provides invaluable fire resistance rating for diverse structural elements. Active and passive fire protection systems form the backbone of fire defense. From fire extinguishers to sprinkler systems and water spray systems, each element is tailored to combat specific situations, fuel types, and hazard levels, ensuring a comprehensive defense strategy. The second part of this course delves deeper into building safety components. Manual fire detection and alarm systems rely on occupants' intervention during emergencies, while automatic systems use specialized detectors. Gas-based fire suppression and smoke management systems ensure swift evacuations. Understanding building characteristics, life safety systems, and egress design facilitate the creation of safer structures. These systems ensure swift evacuations during emergencies, considering refugee areas and fire compartmentation. Thank you. Welcome learners. Step into our comprehensive fire and life safety course series where your safety takes center stage in any setting. In a world teeming with potential risks, arming yourself with the knowledge to safeguard lives becomes paramount. Our journey begins with a deep dive into the basics of fire protection systems. Here, we will unravel the intricacies of life safety systems, indispensable for swift evacuations during crises, and explore compartmentation in buildings, pivotal for containing fires and minimizing their impact. Next, we venture into the realm of piping and instrumentation diagram and pump GA, offering indispensable insights into the layout and functionality of fire protection systems. We will cover everything from fire hydrant system essentials to pump and sump capacity considerations, firefighting pipes and fittings, and a comprehensive overview of the foam suppression system vital for effectively combating diverse fire scenarios. Our exploration doesn't end there. We'll delve into the core of the sprinkler system, a stalwart in fire suppression. Alongside, we will deepen our understanding of firefighting pipes and fittings, pivotal in delivering water to fire locations, and explore alternative suppression methods like water spray and water mist systems. Additionally, we'll equip you with knowledge about fire extinguishers and their classifications, empowering you to make informed choices in fire emergencies. As we progress, we shift our focus to types of fire detection systems crucial for early detection and alarm activation. From selecting detectors based on hazard assessments to understanding fire alarm notification devices and optimizing detector location and coverage, we leave no stone unturned. We'll also explore the integration of fire alarm systems with building systems and the significance of fire and emergency safety signages in bolstering emergency response protocols. Let's begin this enlightening journey to become vigilant advocates for fire and life safety. Together, let's foster safer environments for all. Enroll now and embark on the mission to safeguard lives and property. Welcome to the Fire and Life Safety course series. Thank you.
Hello learners, welcome to this topic on case study on life safety evacuation. In this topic, we will see one of our prestigious projects which has been executed in recent years. The following were the details of the building that we have obtained from the design intent from architect. The name of the building is STB 3 Skill Development Building. The building total height is 60 meters. The number of floors in the building includes the stilt and 13 floors. The type of operation in the building is that it would be used as an office. The building area is 50,000 square meters approximately. The floor to floor height would be 3.9 meters. A life safety system, as we all know, it is an important aspect of any building. It is very important to take necessary precautions and measures to keep both the people and property in a building safe during unforeseen emergencies like fire, earthquake and cyclones. We will refresh our learning about the basic concepts of life safety design, systems and their aspects in this session. While we study these theoretical aspects, we shall also take up a case study wherein we will apply all our learnings and determine if the building is safe for occupants. Let us now look at the case study on what we have learned in this module so far. Here you can see the levels of each floor along with the formed ground level. The formed ground level or FGL is usually the ground level at the perimeter of the building, that is road level. The floor finish level or FFL is usually the level of each floor with respect to any reference levels. Elevations are important to a fire engineer to classify the building. In our previous session, we have learned about the classifications based on the building height and high and low rise buildings. The total height of the building is measured from the lowest ground level to the last usable floor level, that is the terrace. For this project, we are going to have a prescriptive design approach, that is, we are going to refer to an existing standard or code. Even though the building is designed based on earlier NBC 2005, it will be counterproductive to follow NBC 2005 for our discussion. Therefore, we will refer to the latest version NBC 2016 for our design. In addition, there is no major revision for life safety features from NBC 2005 to NBC 2016, so this should not create any trouble. The first step is to find the building classification. Since this building is used for official purposes and its associate business, it can be categorized as Group E occupancy or a business building. As this building is not an industrial occupancy, we are not going to classify this building based on the hazard type. This building falls under type 2 construction and hence accordingly fire rating of structural element shall be proposed from table 1 of NBC. The first step is to design and locate the means of egress for the building. As the floor areas are almost the same, let us go to the 10th floor for doing this. First, we must arrive at the number of occupants using table 3 of NBC 2016. The second step is to fix the width of the exit door and stair based on the number of occupants. Finally, we must locate the exits based on the travel distance allowed for business building in table 5 of NBC 2016. Step 1, Egress design. Following would be the number of maximum occupants expected for office classification. Occupant load factor OLF is equal to 10 meter squared per person. Area of 10th floor is equal to 3500 square meter approximately, and this must be gross floor area without reducing any portion of it. Number of occupants, floor area by OLF, that means 3500 by 10, 350 persons. Therefore, the permissible occupants for the floors of this building are 350. The next step is to find the total exit width required for the number of occupants obtained above. As we are doing this for the 10th floor, our primary means of egress are fire staircases. So, we must obtain the required fire staircase width. Let us calculate the exit width requirement. The minimum width required as per NBC 2016 for business occupancy is 1.5 meter. Number of occupants 350 persons. As per table 4, capacity factor for business occupancy, stair width per person is 10 mm, door width per person is 6.5 mm, stair width required, number of occupants multiplied by stair width per person is equal to 350 into 10 is equal to 3500 mm, that means 3.5 meter. So, we can say that our building requires a minimum of 3 staircases with a width of 1.5 meter or 2 staircases with a width of 2 meter. So, the total width is more than 3.5 meter. Now, to decide this, we must check the travel distance requirement also parallelly. To arrive at the number and location of exits, we must consider the travel distance limit as well. Travel distance requirement. As per table 5, for business occupancy, the maximum travel distance allowed is 30 meter. However, our building is a sprinkled building. So, we can add another 50%, that is 15 meter to the original requirement of 30 meter. So, the allowed travel distance is 45 meter. The minimum door width required for business occupancy is 1 meter. Similar to the stair calculation, we can get the width required for the door as well. The door width required is what? 2.275 meter. With the above details, we can locate the means of egress as shown in the plan. There are no ramps to be considered here, but if there are any ramps, the egress width of other elements can be reduced. It can also be noted that the dead end of the corridor for this occupancy is 15 meter, nothing beyond that is permitted. Now, we must locate the refuge areas, the design of fire compartmentation and the fire rating of the building. We have already discussed that we must provide a refuge area for a building with a height of more than 15 meter. First, the refuge area shall be provided on the floor just about 24 meter and from there on every 15 meter. Therefore, our building, the first refuge area would be on the 6th floor at 24 meter level. The second refuge area would be on the 10th floor at 39 meter level. The compartmentation. Let us look at fire compartmentation. The building is divided into 2 compartments, with each compartment having an area of 1300 square meter. We know from NBC 2016 that the maximum compartment size for a business occupancy building shall be 3000 square meter. This is to avoid the spread of fire from other parts of the building. The fire tower is provided in the core of the building as shown in the plan. Fire rating requirement. The fire rating of service rooms and other components shall be done as per the table shown here. This plan shows the various aspects of the means of egress. The stairwells are marked in purple color. The total number of stairways is 4. 2 stairways with 1.5 meter width and other 2 stairways with 1 meter width. All the stairwells have doors that are 1 meter in width. The egress route of the remote area is indicated in an orange circle. This indicates the egress route. The refuge area is also provided at the periphery of the building so that if someone is stuck and cannot escape through the staircase, they can be in a refuge area until the rescue team arrives. Since this building is more than 3000 square meter, it shall have a minimum of 2 compartments. The compartment line is indicated in red lines. We can also make sure that at least one staircase is available for one compartment. Direction signage shall be provided at strategic locations to aid the safe evacuation of the people during an emergency. Now, we must see that refuge areas are provided as per the calculations, floor area and number of occupants. We have seen the number of fire compartments and fire rating of compartment, which is 2 hours or 120 minutes. We have also seen the travel distance permissible and whether we can achieve the travel distance. The fire staircases are provided with stair pressurization to avoid egress of the fire or smoke into the stair. The fire staircases and the core portion, which is part of the means of egress, shall be provided with the emergency lights with the secondary power supply as a backup. Smoke exhaust systems are not considered since the pressurization system is considered for staircases. We have come to an end of this topic. Hope you have learned interesting things here. Hello learners, welcome to the topic on building characteristics and components. As we all are aware, buildings in modern days are often complex and mixed occupancies. The demand for such buildings has increased and also increased the risk of the people occupying or using them. Moreover, buildings behave differently in different conditions. It is therefore important for a designer to understand the characteristics before constructing the building. The building components can be broadly classified into structure, architecture and MEP. The structural components include beams, slabs, columns, foundations that give structural stability to the building. These skeletal components are the base for carrying a load of the building. These components are also responsible for transferring loads during heavy wind and seismic activity. In most of the cases, the structural system provides safety to the occupants. The architectural components include the masonry wall, doors, windows, facade, which give the unique design of the building. It also defines the exterior or the elevation of the building. In MEP, it is further subdivided into various engineering services, namely HVAC, electrical system, extra low voltage or ELV system, PHE, FPS and piping. If we have to correlate the basic engineering disciplines to various systems of MEP, then HVAC, FPS and piping will be a part of mechanical engineering, electrical systems will be part of electrical engineering, ELV will be part of electronics and instrumentation engineering, and PHE is a part of both civil and environmental engineering. Let us now look at the classification of MEP components one by one. Heating, ventilation and air conditioning. HVAC systems provide the conditioned air and thermal comfort atmosphere in the building. In the case of hilly areas, it also provides the heating system. It also provides and maintains the indoor air quality for buildings through treated fresh air fan and by maintaining RH. These systems provide the required thermal comfort using a chiller, cooling tower, heating equipment and AHU. Some of the HVAC systems also include smoke management. In case of smoke or fire, the smoke extraction fan will activate and throws the smoke out from the building. Electrical systems. Electrical systems provide the interfacing of the power user and service provider. It feeds power to almost all the energized equipment including HVAC and other critical systems. Apart from depending on the service provider, the system will have to an alternate source like distributed generation or DG and renewable sources like solar and wind. It includes a provision for HT metering panel, substation, DG, main LT panel, cabling, switches, wiring and so on. Extra low voltage system or ELV system. The extra low voltage system is like the brain of our body. It performs all the signaling, communication in the terms of building management, security control system like access control, CCTV and so on. The ELV system also has the capability of emergency voice evacuation public announcement systems to specific zones on a specific floor in a building for phased evacuation. Public Health Engineering System or PHE. This system provides essential water supply, water conservation, waste disposal and treatment in a building. It includes water treatment plant or WTP, sewage treatment plant or STP and effluent treatment plant or ETP, water pipelines, sewer, waste and stormwater networks and so on. Fire Protection System or FPS. The fire protection system provides safety to the occupants and the building by deploying the right type of fire protection system. This is similar to the immune system in our body. In case any emergency, the system will trigger various actions to suppress the fire. The fire protection system also includes detection systems like smoke detectors so that we can automatically detect smoke and trigger activation of many life safety systems. A gas-based fire suppression system is used in critical areas like server room, data centers and main electrical panels. Process piping. Some critical projects require piping system. They are cooking fuel like LPG, PNG and so on. Aviation fuel hydrant in this case of airports. Medical gas pipeline system or MGPS in the case of hospitals. Compressed air system in the case of maintenance areas like sheds and factories. Now, let us see some of the common building components typically used in buildings. Reinforced cement concrete for floor slab, columns, column capitals, beams, water sumps and foundation. Bricks of clay, sand lime, aerated concrete for walls and partitions. Steel frame for ceiling and supporting structures. Metallic or plastic pipes for wet services. Cables or wires for electrical equipment. Metallic ducts for carrying conditioned air on exhaust air. Interior finishing materials like carpets, wallpapers, curtains. Cladding materials for surface finishes, namely aluminum composite panel or ACP, aluminum, SS sheeting and so on. Cladding materials for thermal insulation. Paints, electrical switch gears, panels, breakers and switches. Metallic containments like cable trays, conduits for carrying cables and wires for low or high voltage electrical equipment or devices. False ceiling boards, namely calcium silicate or gypsum. Wooden or metallic doors and windows. Glass panels used for facade and partition. Learners, hope you are clear with the building characteristics and components. Hello learners, welcome to this topic on Introduction to Fire and Fire Protection System Part 2. Building classification is done based on the usage and the anticipated number of occupants. This is of primary importance to decide about the life safety features required for the building. As per NBC 2016, buildings are classified into the following categories. Group A. This group includes lodging, private dwelling, apartments and hotels, and mostly these areas where it provides residence and sleeping accommodation for general people. Group B. This group includes all educational institutions, namely schools, colleges, training institutions, coaching centers. For example, schools, colleges, other training institutions involve assembly for inspections. Group C. This group includes all hospitals, clinics, custodial institutions, penal and mental detention centers, prisons, etc. For example, buildings are used for purpose of medical or other treatment or care of persons suffering from physical or mental convalescence or aged persons, and for penal or correctional detention in which the liberty of the inmates is restricted. Group D. This group includes places where assembly takes place. For example, theatres, malls, multiplexes, religious institutions, airport terminal buildings, assembly halls, auditoria, exhibition halls, museums, skating rinks, gymnasiums, restaurants, dance halls, club rooms, and marine public transportation services. Group E. This group includes places such as offices, banks, laboratories, data centers, call centers, etc. For example, buildings used for a transaction of business, for the keeping of accounts and records and similar purposes, professional establishments, service facilities, city halls, town halls, courthouses, libraries. Some more examples are office spaces, banks, offices of architects, engineers, doctors, lawyers, post offices, police stations, laboratories, OPD clinics, research establishments, electronic data processing center, computer installations, and IT parks. Group F. This group includes places such as shops, stores, supermarkets, markets, display and sale of merchandise, either wholesale or retail departmental stores. Group G. This group includes places that are serving industries, namely industrial production, maintenance sheds, and so on. For example, buildings or structures in which products or materials of all kinds of the properties are fabricated, assembled, manufactured, or processed, such as assembly plants, industrial laboratories, dry cleaning plants, power plants, generation units, pumping stations, fumigation chambers, laundries, buildings or structures in gas plants, refineries, dairies, and sawmills. Group H. This group includes places with storage hazards like warehouses, godowns, MLCP, and so on. For example, buildings used for storage and sheltering, including servicing, processing, or repairs incidental to the storage of goods, ware and merchandise, warehouses, cold storage, freight deposits, transit sheds, storehouses, trucks and marine terminals, garages, hangars, grain elevators, barns, and stables. Group J. This group includes places with hazardous goods are stored, used, and being produced or manufactured. For example, storage, handling, processing, manufacturing of highly combustible or explosive materials. Now, we will learn about the characteristics of building based on the hazard classification contained in it. The understanding and classification of hazards are very important as it gives insights on why it is hazardous and what precautions must be taken while designing these hazardous buildings or occupancy. Many guidelines classify the hazard which is more or less similar, and we take NBC, National Building Code, as a reference to determine the classification. The major classification listed in National Building Code and Indian standards are listed here. Light hazard, occupancy with the relatively low level combustible load; moderate hazard, occupancy with the relatively medium level combustible load; high hazard, occupancy with the relatively high level combustible load. The learner is to note that these guidelines set by the standards are only the minimum basis set for assessing the hazards. The fire engineer shall carry out a detailed study along with the architect of the hazard when there exist multiple hazards in the same premises. The most hazardous area will define the hazard type of the entire premises. Further, NBC also categorizes the building hazard based on its height. The logic behind categorizing based on height is very simple. The lesser the height of the building, the evacuation becomes easier. Whereas the case of high-rise building like skyscrapers, the evacuation is either difficult or impossible through snorkels and so on. The term low-rise building are relative and subjective. In the case of NBC, buildings that are less than 15 meters in height are termed as the low-rise building. In some other codes, the low-rise building is categorized based on the number of stories. Similarly, buildings that are over 15 meters in height or more than specified stories are called high-rise buildings. In most cases, the high-rise buildings are treated as hazardous relative to low-rise buildings, and hence the fire safety recommendation for high-rise buildings is relatively high. For example, for the same building, category and occupancy, if it is low-rise, a sprinkler system may not be required, and if it is a high-rise building, a sprinkler system is required. So, learners, we have come to the end of this topic and trust the session was very quite interesting. Thank you, learners.
Let's start with the topic on means of egress and fire rating requirements of buildings. At the end of this topic, you should be able to explain the importance of life safety and a fire resistance rating, describe the different components of means of egress. Let us learn about the importance of means of egress systems and fire rating of building components. Reduced risk to occupants. Occupant safety is important during emergencies such as fire. Life safety systems provide adequate measures to ensure that occupants leave the building safely and uninterruptedly. Early and safe occupant evacuation. Facilitate the easy evacuation of occupants to the point of safety or an area outside the building. Reduces potential risk to property. Constructing the building with right materials ensures that fire risks are avoided. Avoids spread of fire. Internal finishes and building components are essentially required to be fire rated to prevent the spread of fire. Provides enough time for safe occupant evacuation. Increased resistance to fire provides adequate evacuation time for occupants to escape. Egress means a pathway to exit. Means of egress for a building is defined as an unobstructed way of travel from any point in a building to a public way consisting of three separate and distinct parts. They are the exit access, the exit, and the exit discharge. Exit access. Portion of a means of egress that leads to an exit. It can be within the occupied space of the building. Exit. Portion of a means of egress that is separated from all other spaces of the building. And it also provides a protected way of travel to the exit discharge. Exit discharge. Portion of a means of egress between the termination of an exit and a public way. Some more components of means of egress are shown here. Exit stairway. It is a stairway used during safe evacuation scenarios. Here, the word safe means safe from smoke or fire. Since these staircases are either enclosed with fire resistance elements or connected to natural ventilation, therefore, the occupants are safe to evacuate. The width of the exit stairway depends on occupancy type and how many people are going to discharge. Exit discharge. This is the final exit point in the building. On the ground floor, it can be the normal entrance. For people on upper floors, their exit is through the staircase and hence their exit discharge will be outside the building or through protected corridors or large lobbies. Exit passageway. It is a connection between the exit stairway and exit discharge. It is also called a protected corridor or protected passageway. Normally, this corridor is enclosed and fire rated so that smoke or fire cannot be ingressed inside the passageway. Some more components of means of egress are shown here. Door opening. It is the effective clear width of opening acquired and available for egress of occupants. Mostly, these doors are just preceding the stairway, and in some cases, these doorways are also used for horizontal evacuation, that is between compartments. Stairway. It is the effective clear width of stairways available for egress of occupants. It is one of the most important and mandatory requirements. Stairway is always available to the occupants when compared to the lift or any vertical transportation. Ramp. It is the gradient or sloped platform for vertical transportation. It is critical, especially in hospitals, for the evacuation of ill patients. Horizontal exit. It is a passageway between compartments where one can take refuge in case of fire in one compartment until the rescue team arrives. It is also called a relatively safe place. Exit passageway. It is the corridor that are either protected naturally or ventilated. It provides a safe passageway from the occupied area to the stairways. Some support components of means of egress are refuge areas, fire lifts, and fire towers. Refuge area. It is an area within the building for temporary use during egress. It generally serves as a staging area that is protected from the effect of fire and smoke. Fire lift. It is used by firefighters during a fire outbreak. An enclosed shaft has a protected area of 120 minutes fire resistance rating comprising a protected lobby, staircase, and a fireman's lift. It is connected directly to the exit discharge or through the exit passageway. These shall also serve the purpose of exit requirements or strategy for the occupants. The respective floors shall be approachable from the firefighting shaft, enabling the firefighters to access the floor and also enabling the firefighters to assist in evacuation through the fireman's lift. Let us summarize all that you have learnt. Exit discharge is the final exit point in the building. A ramp is a gradient or sloped platform for vertical transportation. A horizontal exit is also called a relatively safe place. Hello, welcome to this topic on fire resistance and fire resistance rating. At the end of this topic, you should be able to explain the fire resistance rating, describe the need for resistance in the buildings. Fire resistance is defined as the resistance to fire offered by an element of a building such as walls, floors, columns, beams, doors, openings, shafts, insulations, and so on. As per NBC Part 4, Fire and Life Safety Clause 2.28 defines fire resistance as a property of an element of building construction and is the measure of its ability to satisfy for a stated period. Some of the criteria are load-bearing capacity or stability R, the ability of a load-bearing element to withstand fire exposure without any loss of structural stability. Integrity E, resistance to penetration of flame and hot gases. Insulation I, resistance to temperature rise on the unexposed face up to a maximum of 180 degrees Celsius at any single point and an average temperature of 140 degrees Celsius. Fire resistance rating, usually specified in terms of minutes, indicates the duration of fire exposure that a construction material can withstand. This rating is derived by conducting a standard fire resistance test. As per NBC Part 4, Fire and Safety Clause 2.29 defines fire resistance rating as the time that a material or construction will withstand the standard fire exposure as determined by fire tests done by the standard methods of fire tests of materials or structures as per the accepted standard.
It is the fire barrier that helps in providing safety to the occupant by enhancing evacuation time. This time can also be sufficient enough to intimate the emergency services and let fire personnel arrive and attend the fire scene.
Constructing a building with materials that prevent the passage of excessive heat, hot gases, or flames allow the occupants enough time to escape. Some occupancies require more evacuation time, such as hospitals, rehabilitation, and retention areas. These occupancies may sometimes require that some of their occupants be moved or evacuated to a separate area that is safe from the effects of fire and smoke. Let us see the need to provide the fire resistance in the building. Some of them are preventing the spread of fire and smoke from one portion of the building to another, provide adequate time for occupants to evacuate the building in case of a confirmed fire alarm, secure the areas that are demarked as escape routes or refuge areas from ingress of fire or smoke, enable the designers to construct taller buildings with larger floor areas. These are usually done by incorporating the required fire barriers. Fire barriers are materials with fire resistance that do not allow the passage of fire from one area to another area. These barriers can be walls, floors, doors, or other building components. Some interior finishes such as wall linings and carpets also act as fire-resistant materials. When a fire incident is confirmed, the first action or response will be to evacuate people from the affected area. Fire resistance can add enough time for the occupants to evacuate. Physically challenged people will require more time for evacuation, and thus appropriate fire-resisting materials are essential. For people evacuation, egress routes are required to be fire and smoke free. If final exits are blocked, refuge areas are required, which will have to be separated from the other portions of the floor by fire-rated barriers. Based on the fire resistance of building components, designers are permitted to have tall structures with larger floor areas. As per NBC 2016 Part 4, provides the permissible height of buildings along with permissible floor areas. Let us see the development and importance of fire resistance requirements in buildings in the NBC. The first revision of the NBC part was modified in 1997 through Amendment number 3 to the 1983 version of the code. This modified version of this part included a few tables for the fire resistance ratings of various building components such as walls, columns, beams, and floors. The code was then revised in 2005. In this revision, the significant modifications incorporated were fire prevention, covering aspects of fire prevention about design and construction of buildings on passive fire protection measures. In the current 2016 revision of the NBC, some of the clauses related to the fire resistance rating were amended. They are Table 1 on Fire resistance ratings of structural and non-structural elements has been updated. The provisions relating to fire separating walls, fire separating floors, and fire partitions have been detailed. Provisions of fire safety requirements of services shafts have been rationalized and updated. The provisions of this code are intended to serve as a model for adoption by local bodies, public works departments, and other government construction departments. It must be noted that the fire resistance rating of building members shall be stringent between NBC and the local bylaws. Some states in India are more specific about passive fire protection and require more fire-resistive materials to be incorporated into the buildings. Let us summarize all that you have learned. Integrity E is the resistance to penetration of flame and hot gases. Interior finishes such as wall linings and carpets also act as fire-resistant materials. Egress routes are required to be fire and smoke-free. Hello, welcome to this topic on stages in fire safety and fire resistance standards. At the end of this topic, you should be able to describe the stages in fire safety, explain the fire resistance tests and standards, describe the fire resisting components. Let us now look at the stages in fire safety. The stages include prevention. This includes identifying and setting aside hazardous materials, then allocating and confining them in specific spaces or areas. Detection. This includes the detection of fire or smoke either manually or automatically by raising an alarm. Early suppression. This includes fire extinguishers and fire hose reels which are used by trained occupants of the building. Evacuation. When the alarm is triggered after confirmation of fire, people evacuation is conducted. Compartmentation. This stage involves compartmentalizing a floor area into zones to curtail the spread of fire. Structural safety. This includes ensuring that the structural members of a building like walls, floors, ceilings, beams, columns are designed to withstand the effects of fire. Firefighting. This is the last stage where the fire runs out of control. Fire personnel is required to douse the fire. Compartmentation and structural safety are dependent on the fire resistance rating of the building components. Fire rating of building elements is an essential passive fire protection method in a building. It gives us a measure of fire resistance of a building component. NBC 2016 recommends a minimum fire rating for the following rooms and structural features. As the table illustrates, the fire rating ranges from 1 hour to 4 hours. For the less critical areas like wet shafts, plumbing, fire hydrants, lift lobbies, and medical gas pipeline system, the fire rating requirement is just 1 hour. In the case of critical shafts like electrical cables, ELV cable shafts, server rooms, fire escape staircases, corridors, the requirement is 2 hours. In the case of a very high hazardous room, namely DG room, transformer room, where there is a potential higher calorific value of heat is generated, the fire resistance rating of 4 hours is required. NBC 2016 mandates splitting buildings into small compartments based on area and separating them with fire-rated walls and doors. For each building occupancy, the compartmentation area is different. All floors shall be compartmented or zoned with an area of each compartment being not more than 750 square meter. In addition, there shall be a requirement of a minimum of 2 compartments if the 4 plate size is equal to or less than the areas mentioned in the table. However, such a requirement of a minimum of 2 compartments shall not be required if the floor plate is less than 750 square meter. Compartmentation shall be achieved using a fire barrier having a fire resistance rating of 120 minutes. Each fire compartment shall have a fire staircase inside itself which exits directly outside the building at street level. Let us now look at the types of building components and their fire resistance rating requirement. These components are broadly classified as structural and non-structural building components. Structural building components, classified as those components of a building that carry or transfer load. Example of these are floor slabs, columns, girders, beams, trusses, walls, and braces. Non-structural building components, classified as those components of a building that do not carry or transfer load. Example of these are dry walls, partitions, cubicles, boards, and so on. Structural designers and architects shall comply with the NBC fire resistance ratings during the design based on the type of construction adopted for the entire building. The minimum fire resistance requirement of building components is prescribed in Table 1, Fire Resistance Ratings of Structural and Non-Structural Elements of NBC 2016 Part 4. This table was amended in the year 2005 by the NBC Council and contains important details about fire resistance ratings. The column on the left indicates the structural component of the building such as walls, doors, floors, roofs, and so on. These components are further subclassified as load-bearing and non-load-bearing members. Load-bearing components are those which carry building loads, while the non-load-bearing components do not carry any loads and are usually used as separations. The columns on the right indicate the fire resistance rating in minutes for each type of construction. The fire resisting rating of building components depends on the type of construction of the building. The type of construction is further dependent on the type of fire zone in which the building or structure is being built. Fire zones permit specific occupancy types to be built in the land parcel. The type of construction of the building is determined by the floor area ratio and the total height of the building. This is explained in section 3.3 of NBC 2016 Part 4. It can be noted in the table that Type 1 construction requires more resistance ratings than the other type of constructions, while Types 3 and 4 requirements are similar. The type of construction for each of these fire zones is also defined in NBC 2016 Part 4. Extracts from NBC 2016 Part 4, Clause 3.2.2.2 indicates the classification of occupancies into fire zones. Further, Clause 3.2.6 indicate the type of construction permitted for each of the fire zones. The fire zones shall be made use of Inland Use Development Plan and shall be designated as Fire Zone 1. This shall comprise areas having residential Group A, educational Group B, institutional Group C, assembly Group D, small business subdivision E1, and mercantile Group F buildings or areas that are under development for such occupancies. Fire Zone 2. This shall comprise business subdivisions E2 to E5 and industrial buildings subdivisions G1 and G2 except high hazard industrial buildings subdivision G3 or areas that are under development for such occupancies. Fire Zone 3. This shall comprise areas having high hazard industrial buildings subdivision G3, storage buildings Group H, and buildings for hazardous uses Group J or areas that are under development for such occupancies. The fire resisting rating of building components also depend on the specific occupancy requirements prescribed in various sections of the NBC 2016 Part 4. Constructing buildings with mixed occupancies are common practice in recent times. These occupancies are separated from one another by incorporating the required fire resistance building component between them. Some of these are provided with an intent to protect occupants from being exposed to high temperatures and fires, while some are provided to restrict the extent of property damage due to fire. Fire tests are performed on building component samples by certified testing agencies using standard test procedure. Fire resistance tests are intended to assess the performance of elements for their load-bearing or fire-separating properties. Widely used fire resistance tests are pool fire tests, burner test, and furnace test. Fire resistance of beams, columns, doors, wall sections is determined by their performance in large furnaces against a standard temperature time curve. These tests are designed for concrete, brick, or steel elements. Fire resistance is usually measured in terms of half, 1, 2, 4, 8 hours of integrity. Some of the standards for testing include European Standards or EN, British Standards or BS, International Standards or ISO. European standards are documents that have been ratified by one of the three European standards organizations such as CEN, CEN-ELEC or ETSI. They are designed and created by all interested parties through a transparent, open and consensual process. European standards are a key component of the single European market. British standards are the standards produced by the BSI group, which is incorporated under a royal charter. The BSI's objectives are to set up standards of quality for goods and services. Also, prepare and promote the general adoption of British standards. The International Organization for Standardization is an international standard setting body composed of representatives from various national standards organizations. Founded on 23 February 1947, the organization promotes worldwide proprietary, industrial and commercial standards. Let us summarize all that you have learned. Compartmentation and structural safety are dependent on the fire resistance rating of the building components. European standard is a key component of the single European market. Fire resistance test is used to assess the load bearing or fire separating properties. Hello, welcome to this topic on construction details of fire resistance rating. At the end of this topic, you should be able to explain the construction details for fire resistance rating, describe the fire resistance rating requirement based on the type of construction and occupancy. We will now understand the minimum construction requirements for building components to obtain the required fire rating. NBC 2016 Part 4 provides a list of pre-tested details in the form of tables that shall be adopted to obtain the required fire rating resistance. This requirement can be met in any one of the following ways. Type of finish of component like plaster, minimum thickness of component with specific material, minimum plaster cover on component, type of reinforcement or stressing, nature of construction. The test certificates for each component may be obtained or required as prescribed by the authority having jurisdiction. The integrity of the assembly of these components can also be tested if specified. Shown here is the Table 10 of NBC 2016 Part 4. This table provides details of solid masonry walls that are required to resist fire from one side at a time. The left-hand column describes the nature of construction and materials, and the columns to the right indicate the minimum thickness of the component, excluding any fire finish, the types of load-bearing and non-load-bearing. The types of walls include constructions made of reinforced cement concrete, unreinforced cement concrete, no fines concrete, bricks of clay, bricks of sand lime, blocks of concrete, blocks of lightweight concrete, blocks of aerated concrete. The types of finishes to these walls include 13 mm cement or sand or gypsum or sand, 13 mm lightweight aggregate gypsum plaster without finish. If these minimum thicknesses are used, then the wall is deemed to be of the fire rating resistance indicated in the table. Likewise, there are many reference tables in NBC 2016 Part 4. Let us take a quick look at them. Table 11 provides details of hollow masonry walls that are required to resist fire from one side at a time. Table 12 provides details of framed construction, load bearing that are required to resist fire from one side at a time. Table 13 provides details of framed construction, non-load bearing that are required to resist fire from one side at a time. Table 14 provides details of framed external walls, load bearing that are required to resist fire from one side at a time. Table 15, 16 and 17 provide details of framed external walls, load bearing that are required to resist fire from inside the building. Table 18 provides details of reinforced concrete columns. Table 19 provides details of concrete beams. Table 20 provides details of concrete floors. Table 21 provides details of concrete floors ribbed open soffit. Table 22 provides details of encased steel columns of size 203 mm by 203 mm. Table 23 provides details of encased steel beams of size 406 mm by 176 mm. Table 24 provides details of timber floors, tongued and grooved boarding or sheets of tongued and grooved plywood or wood chipboard of not less than 21 mm finished thickness. Table 25 provides details of timber floors, tongued and grooved boarding or sheets of tongued and grooved plywood or wood chipboard of not less than 15 mm finished thickness. Table 26 provides details of timber floors, any structurally suitable flooring of timber or lignocellulose boards. To make it simpler, a table is prepared from NBC 2016 Part 4 as a ready reference for the learner. This table consists of the type of building component, the major component used, the construction type of the building, the type of occupancy, the fire resistance requirement of the component in minutes, the reference number from NBC 2016 Part 4. The components described in these tables include opening, walls, door, wall and door, passageway. The type of occupancy listed in these tables include unpressurized area, storage, hazardous, residential, institutional. It is time for some exercise. Let's now review our understanding so far. Find out the fire resistance rating in minutes for the layout provided. You can use the tables to get your answers. Let us summarize all that you have learned. NBC helps to obtain the required fire rating resistance. Table 19 of NBC 2016 provides details of concrete beams. Table 22 provides details of encased steel columns of size 203 mm by 203 mm.
Hello learners, welcome to this topic on Egress components and their sizing, part 1. In the previous week, we have learned about basics of fire protection and life safety systems. Followed by those, we had learned about building characteristics and their hazard types. In this topic, we will be seeing one of the most important aspects of the life safety system. They are the means of egress and the fire rating of buildings. Fire protection and life safety systems include building exit systems, fire alarm systems, and fire suppression systems. Building exit systems play a very vital role in ensuring occupant or people safety in case of emergencies. The egress means a pathway to an exit. Means of egress for building can be defined as an unobstructed way of travel from any point in a building or a structure to a public way consisting of 3 separate and distinct paths. They are the exit access, the exit, and the exit discharge. In simpler terms, it is the escape route that the occupants may take to exit the building during a fire scenario. Now, let us look at 3 distinct paths one by one. The exit access. That portion of means of egress that leads to an exit. It can be within the occupied space of the building. The exit. that portion of means of egress that is separate from all other spaces of the building or structure by construction, location, or equipment as required to provide a protected way of travel to the exit discharge. The exit discharge, that portion of means of egress between the termination of an exit and a public way. For the safe exit of people from a room, a doorway is required. NBC mandates minimum door width required for each building category. Let us now look at the doorway design. The actual door width required will again depend on the number of occupants. The doors may be either single leaf or double leaf, which are equal width or unequal width, depending on which sides. They are fire-rated doors that will resist the smoke and fire without losing their mechanical strength. Fire doors are provided with automatic glow closures. If the functionality of the area requires the fire door to remain open, then the electrically actuated magnetic door holders shall be provided, which will be deactivated in case of fire or smoke. The width of the door also cannot be too small for occupant evacuation. That's where codes and guidelines limit the minimum size of doors to 750 mm or 1 meter. However, the higher limit depends on the egress capacity and stairway width. The minimum width of doorways is actual width available for occupants to evacuate. It should be clear of any obstructions. Even the door frame width shall not be included. Stairway is the effective clear width available for egress of occupants. It is one of the important mandatory requirements since stairway is always available to the occupants when compared to a lift or any vertical transportation. There are two types of staircases in a building. They are internal and external fire exit staircases. The design of the staircase involves the following factors. Exit staircases shall be located based on allowable travel distance to exit as per Table 5 in NBC 2016. See the travel distances section for details. All exit staircases shall discharge at the level of exit discharge to the exit discharge either directly or through an exit passageway or through a large lobby. Staircases width shall be arrived based on the capacity factors given in Table 4 in NBC 2016. Staircase thread, minimum of 300 mm. Staircase riser, maximum of 150 mm. The maximum number of risers per flight shall be 12. The minimum stair headroom required is 2200 mm. Fire staircases can be either external or internal type. External staircases are provided on external wall of facade and it discharges directly to the outside of the building. As per NBC 2016, at least 50% of staircases shall exit directly or shall exit through completely fire-rated passageway. Stairs, whether interior or exterior to a building, serve multiple functions including allowing normal occupant movement among the floors and providing emergency egress in case of fire. It also facilitates rescue and fire control operations conducted by firefighters. The stair headroom is the minimum height achievable inside the staircase. It is the measure between the finished floor level of the staircase to the soffit of the slab or beam above it. The tread is the length of each stair where the occupant's foot is rested. It cannot be very small, otherwise occupants will trip from the escape, especially during an emergency. Hence, there is a limiting factor for this in the codes. The riser is nothing but the height between each stair. It cannot be too high, otherwise people will find it difficult to negotiate. This factor is also limited and the upper limit is fixed for various occupancies. For example, in a residential building, it can go up to 190 mm and in other buildings, it cannot be more than 150 mm. Also shown is a table showing various building classifications with minimum stair width required. Corridors are passageways that lead to an exit staircase or door. The following factors play a vital role in the design of corridor. Corridor shall be of a width not less than the calculated aggregate width of exit doorways leading from them in the direction of travel to an exit. In the case of buildings where there is a central corridor which is part of an exit axis, the doors of rooms, except for the rooms having assembly occupancy, shall open inwards to permit smooth flow of traffic in the corridor. This is to avoid hindrance to the ongoing egress occupants, to prevent someone from opening the doors of the rooms outwards. The common path of travel in a corridor shall be 6 meters. The dead end corridor length in exit axis shall not exceed 6 meters for educational, institutional and assembly occupancies. For other occupancies, the same shall be 15 meters. Corridors shall be either naturally ventilated or pressurized. If pressurization is not done, a smoke extraction order shall be provided. This will ensure the corridors to be smoke-free while evacuation. Ramps can be considered as exit passage if it is provided with a fire sprinkler system. The following are some of the design aspects of fire exit ramps. As per NBC 2016, the slope of a ramp shall not exceed 1 in 12, which is 8%. Ramps shall have landings located at the top and at the bottom, and doors opening into the ramp. Handrails shall be provided all along the ramps on both sides. There shall be mandatory landing after continuous length of 9 meters of the ramp. It is generally required in hospitals where transportation of patients are necessary. In those cases, the width shall not be less than 2.4 meters. The entry into the ramp shall be through a fire-rated door and thus will prevent the smoke of fire to get ingressed into the ramp. The final exit from the ramp shall be outside the building. Now let us look at the horizontal exit. Horizontal exit is a defend in place or a staging arrangement providing safety from fire and smoke originating from the area of incidence by allowing alternate egress from a compartment to an area of refuge or another compartment of the same level. A horizontal exit shall be through a fire-rated door of 120 minutes rating in a fire-resistant wall. Horizontal exit requires separation with the refuge area or adjoining compartment through 120 minutes fire barrier. This strategy is very important in case of hospitals where evacuation of occupants who are under ambulatory care is critical. Therefore, for a shorter duration, the occupants will be moved to a relatively safer compartment using a horizontal exit. An exit passageway serves as a horizontal means of exit travel that is protected from the fire like an enclosed interior exit stair. It can be used to preserve the continuity of the protected exit by connecting the bottom of one stair to the top of the stair that continues to the street floor. The exit passageway is also called a protected corridor, where the enclosed space consisting of walls, doors are fire-rated. It is to ensure that it is relatively safe from the occupied or fire-affected area. To keep the fire and smoke away from the exit passageway, the space is generally pressurized. This pressurization system will keep the smoke or fire away from the protected corridor. Alternatively, we can also do a smoke extraction system for these exit passageways where the centralized fan will suck the smoke and provide fresh air. Let us discuss the design of the refuge area as per NBC 2016. Refuge area shall be provided in buildings of height more than 24 meters. It is provided to accommodate the occupants of 2 consecutive floors by considering the area of 0.3 square meter per person for the calculated number of occupants. It shall include additionally to accommodate 1 wheelchair space of an area of 0.9 square meter for every 200 occupants, a portion thereof based on the occupant load served by the area of refuge, or a minimum of 15 square meters, whichever is higher, shall be provided as under. The refuge area shall be provided on the periphery of the floor and open to air at least on one side, protected with suitable railings. Refuge area shall be provided immediately above 24 meters and thereafter at every 15 meters or so. The refuge area shall be fully sprinklered and shall connect directly to the fire tower. Hope you have learned many things about egress components. Let's see you in the next session. Thank you. Hello learners, welcome to this topic on egress components and their sizing part 2. Let us now discuss fire tower design. A fire tower or firefighting shaft is expected to help the firefighters move from one level of the building to another level of a building under fire. The fire tower consists of a fireman's evacuation lift, the fire escape staircase, the fire escape hydrants and hose reels, a fireman's talkback system, and an emergency evacuation plan. One fire tower shall be planned for each residential building, an educational building, and each compartment of an institutional, assembly, business, and mercantile occupancy types. For other occupancy types, the requirement of a firefighting shaft shall be ascertained in consultation with the local fire authority. The firefighting shaft shall necessarily have connectivity directly to the exit discharge or through the exit passageways. In case if the fire tower is either naturally or cross-ventilated, the fire tower enclosures are not required. Now we will see the fire lift, or also known as fireman's lift. It is a part of a fire tower which is also a component of means of egress. Fireman's lifts are invariably associated with all the features and requirements of a firefighting shaft. Such lifts are installed to enable fire service personnel to reach different floors with minimum delay. This lift also serves the purpose of meeting the requirement of an evacuation lift for assisted evacuation. This lift shall have the fireman toggle switch. NBC 2016 does not recommend using lifts for the evacuation of people from the building during a fire accident, but codes like NFPA allow the use of lifts for the evacuation of people, especially for very tall buildings if the lift has the following features: 2-hour fire rated enclosure, fireman toggle switch. Let us now look at the travel distance. The distance to be traveled from any point in a building to a protected exit or an external escape route or final exit is measured along the line of travel. Table 5 of NBC 2016 stipulates the allowed maximum travel distance to exit. Exits in a building shall be arranged in a way that the maximum allowed travel distance is not exceeded. Travel distance is one criterion to locate doors and stairways in a building. The common path of travel in a corridor shall be 6 meters. The dead-end corridor length in exit axis shall not exceed 6 meters for educational, institutional, and assembly occupancies. For other occupancies, the dead-end corridor length shall be 15 meters. The code also gives relaxation for a fully sprinklered building where the travel distances to the exit staircase can be increased by 50%. For example, if an assembly space is having sprinklers, then the travel distance can be increased from 30 meters to 45 meters. The measurement of travel distance shall be between the occupied space to the safe exit. The safe exit can be an egress passageway, staircase, refuge area, or even outside the building or the terrace of the building. While calculating travel distance, the actual path of travel, considering the furniture layout or any hindrance, shall be taken into account. In Figure A, the travel distance shall be measured as L1 plus L2. In Figure B, the travel distance shall be measured as L3 plus L4 plus L5. By measuring the actual path of travel to the exit, we get the practical or actual distance in which the occupants need to move or travel. In many cases, the furniture layout or room layout may not be available while checking the egress. In such cases, the risk is always there. Sufficient mitigation measures shall be taken into account in those cases. Next, we'll be seeing the important factor, that is the occupant load factor, or OLF. OLF is used to determine the total occupants in the respective occupancy. For calculating this occupant load, we need to know the gross area of the floor. By dividing it by the occupant load factor, we get permissible occupants for the corresponding floors. The egress calculation is done for these number of occupants only. For example, in an office building of business occupancy of 1000 square meter gross area, then the permissible occupants is 1000 square meter of floor area divided by 10 square meter per person, which is equal to 100 persons. Similarly, the OLF can be applied to other occupancy areas to determine possible occupants on that floor. If closely observed, the lesser the OLF, the higher number of people are permitted. Assembly buildings has higher occupants and storage has the least occupants. Now, let us look at door and stair capacity. For a room or a floor in a building, apart from the minimum door and stair width requirement, the actual number of people also shall be considered to arrive at the final width. NBC 2016 requires a minimum of 2 exit staircases for a building with a floor. Let's see how to do this. Initially, we must calculate the total number of people that can occupy the given space. For this, we must refer to Table 3, the occupant load, of NBC 2016 and find out the occupant load factor for the building occupancy under consideration. Next, we must divide the floor plate area or room with the occupant load factor, and this will give the maximum anticipated number of people for the building. Number of occupants is equal to floor area divided by OLF. Once the maximum number of people is obtained, we must refer the table of capacity factors in NBC to arrive at the width required for the door or stair. The width of stairs required shall be reduced by increasing the number of stairs so that the total width requirement remains the same. NBC 2016 mandates proper illumination and marking of egress as described below. Egress illumination in the path of egress shall be provided with emergency lighting with UPS backup or any other secondary power supply backup, so that in the event of power failure during a fire, evacuation of people is not hampered. Minimum 90 minutes of power backup shall be made available. Egress marking is used for guiding people to the safe point through an egress path during a fire. It has proper direction markings. They shall be internally illuminated or photoluminescent type. Photoluminescent safety signages is generally provided for fire equipment for easy identification during the fire scenario. The photoluminescent safety signage will glow in case of darkness. Now we will see the travel distance. Travel distance is the measure of distance taken by an occupant to reach the nearest exit. In this example, consider a student sitting at the first row in a fully sprinklered classroom at position A. When a fire alarm is activated, the student at location A will have to egress across the classroom to point B. This distance from A to B is called the common path of travel. This is recorded as 9 meters from point A. Point B provides 2 options for the student to escape. The student either takes a route to the west portion of the classroom through the door located at point B, or continues to run towards the extreme left to the east to reach the fire tower. The distance from A to C is called the total travel distance. The student takes 9 plus 27 meters, that is 36 meters, to travel to the nearest exit. The corridor leading to the staircase will have to be sized to accommodate the occupants running towards the exit staircase. From the NBC 2016 requirements, the minimum width of the corridor of an educational building should not be less than the calculated aggregate width of the exit doorways leading from them in the direction of travel to the exit. Considering a total occupancy of 100 students on the floor, the egress width of the corridor will be based on Table 4 of NBC 2016 Part 4. 100 into 6.5 millimeters is 650 millimeters or 0.65 meters. Considering the minimum door width requirement, the corridor width shall be not less than 900 mm for such occupancies. The stairway indicated in the plan will have to cater to an occupant load of 100 students. Using Table 4 of NBC 2016 Part 4, the total stair width required for 100 students escaping from this staircase will be 100 students into 10 mm per student, which is 1000 mm or 1 meter. Notwithstanding the above, the minimum stair width to be provided in an educational building is 1.5 meters as per section 4.4.2.4.3.2 of NBC 2016 Part 4. Therefore, the width of the staircase shall be 1.5 meters. We have come to the end of this topic. Hope you have learnt many things. Thank you. Hello learners, welcome to this topic on fire protection in buildings, resistance rating and restrictions part 1. Let's start with this topic on passive fire protection or PFP. It's an integral component of structural fire protection and fire safety in a building. PFP attempts to contain fires or slow the spread. PFP works by limiting the spread of fire, heat and smoke by containing it in a single compartment in its area of origin, protecting escape routes and providing essential escape times for occupants, protecting a building's crucial structural members, and protecting a building's assets. PFP products that are installed in a building to improve its fire safety include fire doors, fire-resistant walls, floors, ceilings and ducts, fire stopping and fire protection for structural members, fire resistance epoxy coatings that can be spray applied, PFP sheet, fire protective boxes or wardrobes, production of vital equipment such as first aid boxes, oil or gas tanks, or other volatile sites to prevent the risk of explosion. Passive fire protection materials insulate steel structures from the effects of high temperatures that may be generated by a fire. Structural fire protection is executed to support the containment and prevention of fire in a building or facility. Even non-combustible materials such as steel can be affected by high temperatures. However, because structural elements are not usually loaded to their full design strength, even bare steel may have sufficient load carrying capacity to withstand the effects of fire. The standard ASTM fire test uses constantly increasing temperatures, assuming that the fire has an infinite supply of fuel and the members are loaded to full design load. When building codes specify fire-resistant construction based on results of these tests, structural steel elements must be insulated with protective materials. These passive fire protection materials can be divided into two categories. They are non-reactive, such as boards and sprays, and reactive, such as thin film intumescent coatings. Fire compartmentation is an important element of passive fire protection. It is achieved by dividing the premises into fire compartments through the use of fire barriers such as fire doors, floors, walls of fire-resisting construction, cavity barriers within roof voids, and fire stopping to surfaces that penetrate through these dividing or separating elements. Providing compartmentation helps in preventing the spread of fire, smoke, and toxic gases, subdividing buildings into manageable areas of risk, providing adequate means of escape, enables time for the occupants to safely evacuate the premises. In simple buildings, the requirement of compartmentation may be less important, and providing a means of escape can satisfy the fire safety requirements. Larger or more complex buildings will make much greater use of compartmentation. Compartment portions of a large floor area will be important to ensure the slow spread of fire and early occupant evacuation. To effectively overcome the effects of fire, heat and smoke, a fire-rated barrier must be complete and whole. There cannot be any such openings in the wall, such as open doors, windows, or holes for wires, cables, ductwork, or pipes. Each of these openings within a fire resistance rated component must be safeguarded with opening protectives. We will refer to some clauses from NFPA that mandate opening protection requirements. The 2018 edition of NFPA 101 Clause 8.3.3 on opening protectives states that every opening in a fire barrier shall be protected to limit the spread of fire from one side of the fire barrier to the other. When openings are needed in fire resistance rated component, they must be properly rated for the fire resistance rating of the wall. Any penetration through a fire compartment such as electrical cable trays, mechanical ducts, pipes must also be provided with the same level of fire resistance as the compartment walls and the floors that they penetrate. Let us consider an example. If a door is needed in a 3R fire rated wall, the door must also exhibit a 3R fire resistance rating capacity. If an appropriately rated fire door is not installed, then the fire resistance rating of the entire compartment is not valid or fair for its purpose. Doors play an important role in keeping fire and smoke away. Fire-rated doors are required to be kept in closed positions to ensure no spread of fire. Doors on staircase enclosures have self-closing devices to return the door in a closed position, thereby maintaining the integrity of the exit enclosure. Keeping fire doors closed is critical if a fire is to occur. Fire doors serve several purposes, such as protecting escape routes on stairs and corridors, slowing the spread of a fire, separating the fire hazards, and providing places of relative safety. Fire doors have two important functions during a fire. When kept closed, they form a barrier to stop the spread of fire. When open, they provide a means of escape. The fire resistance rating of doors in egress routes, service rooms, and shaft doors is provided in this table. Read through this table for a better understanding. This table will be useful for the upcoming sessions. As previously discussed, we will now recap our awareness of the fire resistance rating of openings. Based on codes and standards, a table is prepared from NBC 2016 Part 4 for your reference. This table lists the type of the building component, the area or major component in which the component is used, the construction type of the building, the type of the occupancy, the fire resistance requirements of the component in minutes, and finally the reference from NBC 2016 Part 4. This table shall be adopted to design the building components. It is in the scope of an architect or a structural engineer to ensure that these fire rating requirements are met. As you are considered to be a fire engineer while you take up this course, you shall ensure to ascertain the fire rating requirements of a building or its components from NBC 2016 Part 4. This table lists the type of openings, the area or major component in which the component is used, the construction type of the building, the type of the occupancy, the fire resistance requirements of the components in minutes, and finally the reference from NBC 2016 Part 4. The components described in these tables include ceilings, walls, floors, access doors and access door assemblies, service access doors, inspection access doors, openings, both horizontal and vertical, and finally enclosures. It is to be noted that a component when installed in a large assembly, as listed in column 2, should perform together with the assembly as intended. The type of constructions included in these tables are types 1, 2, 3, and 4. The type of occupancy listed in these tables include residential, educational, institutional, assembly, business, mercantile, industrial, storage, and hazardous areas. Care must be taken to enforce stringent requirements specified for each type of occupancy. These specific requirements are listed in Section 6 of NBC 2016 Part 4. It is time for some exercise. Let us now review our understanding so far. Find out the fire resistance rating in minutes for the layout provided. You can use the tables to get your answers. Let's see this example of fire resistance rating in minutes for the layout provided. Hope you have learned many things about passive fire protection. Thank you. Hello learners, welcome to this topic on fire protection in buildings, resistance rating and restrictions part 2. In this topic, we will be seeing the fire stopping materials and fire resistance rating requirements for the building. A fire stopping or fire stop is a form of passive fire protection that is used to seal around openings and between joints in a fire resistance rated wall or floor assembly. Fire stops are designed to maintain the fireproofing of a wall or floor assembly, allowing it to impede the spread of fire and smoke. Types of fire stopping products commonly used are caulking sealants, putties, mortars, pillows, boards, spray-on mastics, pipe collars, intumescent sleeves, joint strips, wrap strips, and pass-through devices. Ultimately, the selection and correct installation of a fire stop can potentially save lives. There is therefore a decision that should involve qualified personnel to ensure effective fire stopping solutions are used. All buildings are different, and it is important to consider not just the product you require, but also the environment and situation into which it is being installed. Specifying fire stopping products is a 4-step process. The fire engineer typically chooses a fire stop method once the following is known: construction details of the floor or wall, opening size, penetrating items, and hourly rating of the wall or floor. Let us now look at the fire resistance rating requirements for service ducts and shafts. Service ducts or shafts are vertical risers in which services such as water pipes, cables, air ducts, gas pipes, refuse chutes, and so on are routed to all the floors of the building for further distribution. These are required to be enclosed and fire rated to ensure that fire does not propagate from one floor to another. Clause 3.4.5.4 of NBC 2016 Part 4 states various fire resistance rating of shafts, ducts, and openings. Openings in walls or floors which are necessary to be provided to allow passages of all building services like cables, electrical wirings, telephone cables, plumbing pipes shall be protected by enclosure in the form of ducts or shafts having a fire resistance of not less than 120 minutes. The inspection doors for electrical shafts or ducts shall not be less than 120 minutes. Further medium and low voltage wiring running in shafts or ducts shall either be an armored type or run through metal conduits. The space between the electrical cables and the walls shall be filled by a fire stop material having a fire resistance rating of not less than 120 minutes. This shall exclude the requirement of fire stop sealing for low voltage service shafts. For plumbing shafts in the core of the building with shaft doors opening inside the building, the shaft shall have inspection doors having a fire resistance rating of not less than 30 minutes. For plumbing shaft doors that open in wet areas or naturally ventilated areas or on the external wall of the building, the shafts may not require doors having any specified fire rating. A note to the learner: in the case of buildings where it is necessary to lower or lift heavy machinery or goods from one floor to another, it may be necessary to provide large openings in the floor. Such openings shall be provided with removable covers which shall have the same strength and fire resistance as the floor. Clause 3.4.5.5 of NBC 2016 Part 4 states fire resistance ratings for refuse chutes. Refuse chutes are defined as chutes in a building in which rubbish and waste are thrown down into the main refuse bins or containers. We will learn about how these chutes are required to be constructed and their fire resistance rating requirements. Refuse chutes, if any provided in a building, shall have been placed at least 1 meter above roof level for venting purposes, and they shall have an enclosure wall of non-combustible material with fire resistance of not less than 120 minutes. They shall not be located within the staircase enclosure or service shafts or air conditioning shafts. Refuse chutes, inspection panel doors and doors shall be tight-fitting with 60 minutes fire resistance. A sprinkler protection system shall be provided for the refuse chutes. Refuse chutes shall be at least 6 meters away from exits. The hazard of an occupancy, as per NBC 2016, shall be the relative danger of the start and spread of fire, the danger of smoke or gases generated, the danger of explosion or other occurrences potentially endangering the lives and the safety of the occupants in the building. Building interior finishes, particularly wall and ceiling linings, play a vital role in the fire growth and eventually in the fire size. It also provides a large unbroken surface over which flames spread. The flame from interior finish may release sufficient thermal energy for the formation of a hot gas layer, which may become thick, attaining high temperatures, and starts descending from the top. At this stage, all the combustible contents as well as the furnishing in the room may simultaneously get ignited, which is known as flashover or full fire involvement. This can happen even in a few minutes. The hazard of an occupancy depends on the contents of the occupancy and their flammability properties. These are usually classified as fire load of each component of the occupancy. In defining the classification of occupancy, a designer or an architect or authority authorized to identification shall review the fire load of each of the components in space and accordingly determine the classification of the hazard. We will learn about the fire resistance rating requirement of interior finishes in a building. But before that, let us learn something about what constitutes these materials in a building. Finishing materials improve the appearance of buildings both internally and externally. Finishes are used in the final part of the construction process, forming the final surface of an element or a building component. They can protect the element they finish from physical impact, water, frost, corrosion, abrasion, and be decorative. There are different types of finishes and methods applied during the construction process of a house, a residential building, a commercial building, or any other type of building project. Interior finishes components are materials such as surface finishes and furniture inside a building. These include reflected ceilings, ceiling lining, wall lining, wooden floors, insulation materials, claddings, renders, carpets, wallpaper, decors, facade, and so on. NBC 2016 Part 4, Clause 3.4.11.1 indicates that the finishing materials used for various surfaces and decor shall be such that they shall not generate toxic smoke or fumes. Wall finishes provide a decorative skin to conceal building components including structural members, insulation, ductwork, pipes, and wires. Good wall finishes are plumb and straight. Surfaces may be smooth or textured, and better wall finishes are durable. Some wall finishes are versatile, taking decorative finishes such as stain, paint, or wallpaper readily. In kitchens and bathrooms, resistance to water damage is an asset. The use of combustible surface finishes on walls and ceilings affects the safety of the occupants of a building. Such finishes tend to spread the fire, and even though the structural elements may be adequately fire resistant, danger to life may result. Interior finishes and space division systems define living spaces of both natural and synthetic materials inside residential buildings. Gypsy board, the prefabricated version of classic wet plasters, is the most often used wall finish. Wet gypsum plaster is cast between paper facings to form large panels that are nailed to light timber or metal frameworks. The joints between the panels are clamped with a hard-setting resin compound, giving a smooth, seamless surface that has considerable fire resistance. Gypsum boards form the substrate to which several other materials, including thin wood-veneered plywood and vinyl fabrics, can be applied with adhesives. NBC 2016 Part 4, Clause 3.4.11.2 states that the susceptibility of various types of wall surfaces to the fire is determined in terms of the rate of spread of flame. Based on the rate of spread of flame, surfacing materials shall be divided into floor classes as follows. Class 1. Surfaces of very low flame spread. Class 2. Surfaces of low flame spread. Class 3. Surfaces of medium flame spread. And Class 4. surfaces of rapid flame spread. Flame spread is primarily a surface burning characteristics of materials, and a flame spread rating is a way to compare how rapid flame spreads on the surface of one material compared to another. Flame spread index is a ranking derived by laboratory standard test methodology of a material's propensity to burn rapidly and spread flames. Examples of these ratings are asbestos cement board having a value of 0 and red oak wood having a value of 100. The ceiling is defined as a non-load bearing element of building construction designed to improve the appearance of a space. The material used for a ceiling should be appropriate for its occupancy. Some common choices are drywall, plaster, wood, tile, and metal. Some of the reasons why false ceilings are provided are fire protection. Some fire-rated ceilings provide horizontal fire separation. These ceilings have a standalone fire resistance rating and are used to protect from fire attacks from below or above. Thermal insulation. These applications of false ceiling creates a gap between the terrace and the ceiling and helps in keeping the room much cooler. Sound insulation. By installing a false ceiling with rock wool, one can block all the outside noise and make space soundproof. Aesthetical. Gypsum board ceilings or false ceilings are aesthetically more appealing. They offer flexibility in creating and dividing spaces and also allow to experiment with shapes and sizes and fallouts. Saves electricity. False ceiling reduces space in the ceiling and it helps in increasing air conditioning requirement and performance. In general, floor covering is a finishing material applied over a floor or subfloor to provide a walking surface. Flooring is very important as a decorated floor will improve your mood and working environment. The most common floor finish is carpeting, most of which is now made of synthetic fibers, displacing the traditional wool and cotton. It can be easily maintained and its soft visual and tactile texture, as well as its sound absorbing qualities, make it attractive for residential use. Hardwoods, primarily oak, birch, and maple, are also used for floors, both in traditional narrow planks, nailed to plywood decks, and as per prefabricated paraquat elements, which are applied with adhesives. In wet or hard use areas, vinyl composition tiles or ceramic tiles are used. Importance of flooring. The flooring is an important part of any interior design and is one of the major aspects that a designer will have to specify. It has to be beautiful and add a sense of personality to the space, and it is also very practical so that it can meet the demands of the customer. The type of flooring depends on the occupancy of a space. For instance, for hotel buildings, beauty and elegance are main aspects. For a business building is comfort, and on the other hand, for industrial buildings or warehouses, wear and tear resistance and functionality are the main priority. Decors are interior furnitures used in a building post-construction, and they play a major part in contributing to the spread of fire in a building. These can be anything between desks, storage cabinets, and bookcases in the office building to sofas, tables, chairs, and beds in residential buildings. According to the National Fire Protection Association or NFPA, the 5 most common causes of fire in commercial buildings are cooking equipment, heating equipment, electrical and lighting equipment, smoking materials, and intentional fire setting. Decors in the vicinity of such fire incidents enhance the fuel supply and thereby cause an enormous amount of heat and smoke to be generated. Upholstered furnitures has long been the leading item first ignited in terms of home fire deaths. Based on data from the U.S. Fire Administration's or USFA's National Fire Incident Reporting System or NFIRS and the NFPA's annual Department Experience Survey, NFPA estimates that during 2010 to 2014, upholstered furniture was the item first ignited in an average of 5,630 reported home structure fires per year. We will learn about the requirements listed in NBC 2016 Part 4 for fire resistance ratings of interior finishes. These requirements are required to be met by architects in their material selection processes. Clauses that govern the adoption are listed for understanding. Clause 3.4.11.3 lists the various types of surface material classes which can be adopted in construction. These include Class 1, may be used in any situation. Class 2, may be used in any situation except on walls, facade of the building and corridors. Class 3, may be used only in living rooms and bedrooms, but not in the rooms on the roof, and only as a lining to solid walls and partitions, not on the staircases or the corridors or the facade of the building. The exhibit from the code is presented. Restricted use of interior finishes in a building is fire command center, fire hose cabinet, and enclosed metro stations. A fire command center is a room or a space that houses all terminals and supervisory or control equipment of the building's fire protection and detection systems. NBC 2016 Part 4, Clause 3.2.12, Para B indicates that a fire command center shall be constructed with 120 minutes fire rating walls with a fire door and shall be provided with emergency lighting. Interior finishes shall not use any flammable materials. A fire hose cabinet is a firefighting equipment that includes a hose reel with actual supply, a water supply stop tap adjacent to the hose reel, a basic length of semi-rigid hose 30-meter maximum in length, and a portable extinguisher. Clause 5.1.1g of NBC 2016 Part 4 restricts the usage of non-flammable interior finishes for a fire hose cabinets. A metro station or subway station is a railway station for a rapid transit system, which is as a whole usually called a metro or subway. A station provides means for passengers to purchase tickets, board trains, and leave to their destination. Most of today's metro stations are underground or enclosed. Clause J 7a of NBC 2016 Part 4 restricts the usage of non-flammable interior finishes for enclosed metro stations. Hope you have learned the fire resistance rating required for the building. Thank you.
Hello, let's start with the topic on needs, roles, and aspects of compartmentation in a building. At the end of this topic, you should be able to describe the need for compartmentation, explain fire resistance and compartmentation. Let us understand the need for compartmentation by comparing the fatality rates in a fire accident. Fire causes 1% of the global burden of disease and 300,000 deaths per year worldwide. Fire disasters destroy cities, families, workplaces, workers, and wildlands and have an enormous impact on human health, the environment, and society. The majority of the fire-related deaths are caused by smoke inhalation of toxic gases produced by fire. Tangible flames and burns are accountable for 30% of fire-related deaths and injuries. The inhalation or exposure to hot gaseous products of combustion can cause serious respiratory complications. Toxic gases and fumes from fire caused 10% of fire deaths worldwide. From the worldwide data, it is derived that 44% of people are killed by inhaling toxic gases, 67% of people died in fire accidents because of smoke inhalation, with smoke travels at the rate of 50 to 300 feet per minute. During a fire, 47% of the survivors cannot see more than 12 feet due to smoke. Compartmentation is a crucial part of the fire and life safety design of a building. NBC 2016 mandates to divide large spaces of the building into smaller spaces with fire-rated walls and doors. This helps to avoid the spread of fire from one part to the other parts of the building. Fire compartmentation is also used to create a safe, protected way of escape for the building occupants. In a 3-story office building with a floor area less than 500 square meter, only one staircase is available for servicing the upper floor. In such cases, The staircase is designed as an escape route and a fire compartment to protect the occupants while evacuating the building. Here, the staircase walls and doors shall be fire rated to withstand the fire for a particular period till all the occupants of the building are evacuated safely. In a high-rise apartment, each apartment is a separate unit. Thus, the fire spread can be avoided. Larger flats may have additional fire compartments to protect the occupants from fire. The following are the risk factors to be considered to mitigate the life safety requirements in a building. Reliance on fire separation or fire compartmentation, mobility of the occupants, the average age of occupants in building occupancy, building usage. Based on these life safety requirements, the compartmentation areas are arrived and mandated by NBC 2016. The wall or floor must remain functional for the designed fire resistance period. The compartment wall or floor should not crack or develop holes that allow flame or smoke and hot gases to pass through. It also needs to maintain a level of insulation so that the non-fire side does not increase in temperature by more than 140 degrees centigrade above ambient temperature. The fire resistance period of a wall or floor or door is measured in terms of time. In some circumstances, that is from 30 minutes up to 4 hours and beyond also. Compartmentation falls into the category of passive or built-in fire protection, which is part of the building fabric and is not required to be activated in the event of a fire. There are no ongoing checks or maintenance regimes associated with the compartment wall or floor. However, the integrity should be maintained for an effective compartment wall or floor. A structure is tested against its load-bearing capacity. It is the ability of the element to withstand the fire without getting collapsed for a while, and the same is measured with the parameter R. Similarly, the parameter E measures the integrity of the structure. That means without developing cracks, preventing the flames from the fire side to the non-fire side of the wall. Parameter I measures the thermal insulation capabilities of the structure. Let us summarize all that you have learnt. Fire causes 1% of the global burden of disease and 300,000 deaths per year worldwide. NBC 2016 mandates to divide large spaces of the building into smaller spaces with fire-rated walls and doors. Compartmentation falls into the category of passive or built-in fire protection system, which is part of the building fabric and is not required to be activated in the event of a fire. Hello, welcome to this topic on fire compartmentation and its requirements. At the end of this topic, you should be able to describe the requirements of a fire compartment, explain fire compartmentation. Compartmentation is a part of passive fire protection system. It is a division of fire-resisting compartments designed to contain the fire for a predetermined duration. Fire resistance periods are not related to the anticipated duration of fire, but the fire loads in the fire compartment. In life safety codes and standards, the purpose of compartmentation is to limit the theoretical maximum size of the fire to facilitate safe evacuation. In other words, compartmentation in a building helps to avoid the damage caused by fire or smoke, protect the valuable items, and limit the damage caused to occupants and property, so that with minimal interruption, the business is resumed easily and quickly. The most identified cause of death from a fire incident is gas, smoke, or toxic fumes. Based on the case study, Fire and Rescue Services reports the majority of fatalities are due to smoke and gas. In addition, an escape route needs to be separated from the rest of the premises by fire-resisting construction for a dead-end corridor or protected stairway. Let us now look at the list of compartmentation that needs to be ensured in a building. Doors, walls, floors and ceilings protecting escape routes should be capable of resisting the passage from smoke for a while, enabling the people to escape the building. The fire resistance should extend up to the floor slab level where suspended or false ceilings are provided. Fire barriers, fire stopping sealants and dampers in ducts must be installed at every crossing on the fire rated wall. Compartmentation is based on a set of rules made by the Building Codes Committee or the local statutory bodies. NBC 2016 mandates splitting the building into smaller compartments to avoid the spread of fire from one part to other parts of the building. Compartmentation area differs from different building occupancies. National Building Code states all floors shall be compartmented or zoned with an area covering not more than 750 meters square. Shown here in the table is the maximum size of the compartment for the basement. Basement car parking areas shall be compartmented for a maximum of 3000 square meter. Basement areas which are not used for car parking shall be compartmented for the maximum of 2000 square meter. If the floor plate is more than 750 meters square, a minimum of 2 compartments is required. Compartmentation shall be achieved by fire barrier having a fire resistance rating of 120 minutes. Each fire compartment shall have a fire staircase inside itself which exits directly outside the building at street level. Now we will see fire compartment requirements inside the building. Each floor in a building shall be at least compartmented into 2 without compromising the travel distance to the exit discharge. The travel distances are based on the recommendations mentioned in local building statutory norms or National Building Code of India and other fire safety recommendations. The escape route travel distances may differ for different building occupancies. The time available to leave a room or compartment of fire origin before being overcome by fire or smoke is dependent on the number of key factors. Let us now look at them one by one. The number and mobility of occupants in the compartment of fire origin, the containment measures of the compartment of fire origin, the geometry of the compartment, means of early warning of fire, fire dynamics, example, the fire load and rate of fire growth, the distance to reach a safe place, protected zone or another compartment, the number and width of exits. Let us summarize all that you have learned. Compartmentation in a building helps to avoid the damages caused by fire or smoke, protect valuable items, and limit the damage caused to occupants or property. Fire compartmentation is based on set rules made by the National Building Codes Committee or the local statutory bodies. NBC 2016 mandates splitting the building into smaller compartments to avoid the spreading of fire from one part to other parts of the building. Hello, welcome to this topic on designing of compartmentation. At the end of this topic, you should be able to explain the principles of compartmentation, describe the components of a fire compartment, explain smoke extraction. Compartmentation is designed to increase the possibility for occupants to escape from the building. Compartment of walls and floors constitute an integral barrier between burning boxes and must give a minimum level of fire resistance as provided under the local building statutory standards or India's National Construction Code. Fire resistance is expressed in terms of the number of minutes of resistance that must be provided in different parts of a building. Doors within compartment walls and other openings have similar fire resistance. Joints between elements that separate the fire should be fire-stopped wall or floor to maintain continuity of resistance. The wall penetrations such as pipes, ducts, cable trays, conduits and other elements should be kept as few as possible in number and should be fire-stopped using fire sealant. The main purpose of structural fire protection is to minimize the risk to the occupants who are not evacuating the building immediately, to reduce the risk of firefighters who engage in rescue operations. Compartmentation ensures that the fire does not spread from one building to another building. To reduce the danger to the occupants of other buildings, one building should be isolated from another either by construction or distance based on the building hazard classification. The distance and relevant boundary between buildings are dictated in local building statutory norms or National Building Code of India. Generally, this influences how the building is used, compartmented, separated from any openings or other unprotected areas in the external wall of the building. A fire stop is a fire protection system made of various components used to seal openings and joints in the fire resistance rated wall or floor assemblies where the fire can spread within the building. A fire stop material play a vital role when a firewall is penetrated by mechanical or electrical services. A fire stop system is installed in the annular space around the penetrating surface to maintain the specified fire rating. In case of a large opening for a fire separation and compartmentation, installation of a fire door and fire window is used. The main components required to achieve proper fire compartmentation within a building are fire-rated wall and floor, fire door, smoke barriers like a smoke curtain, fire curtain, fixed smoke or fire board, water curtain in basement parking areas, fire stop sealant. Compartmentation can only be effective if all fire protection systems act or respond together. Both passive and active fire protection systems are essential in avoiding or mitigating a fire. Let us see the different passive and active components in a fire protection system. Fire doors, fire-rated walls, fire-rated windows, fire stop sealants, dedicated exit or stairways, and signages fall or the passive fire protection system. Automatic sprinkler systems, supply air or exhaust system, detection system, fire or smoke dampers, fire or smoke curtains are the active fire protection systems in a building. A passive fire protection system helps in containing the fire within a compartment for a stipulated time as per the requirement mandated in the building codes. The passive fire protection system also protects the building from heat transfer from one zone to another zone of the building. The system helps the occupants move out of the building through the designated exits. The fire stop sealants also play a major role in compartmentation, which is used to seal the openings in walls and floors provided for the electrical and mechanical services. Compartmentation can also be achieved by the active fire protection system, including automatic sprinkler system, spray system, the water curtain spray nozzles, fire or smoke curtain system, the smoke or fire dampers located on the HVAC ducts crossing the fire-rated walls used for compartmentation in the event of a fire. Both active and passive systems put together to form a complete fire protection system. Let us study the smoke extraction in or within a compartment. The smoke formed by the product of fire shall be extracted from the floor to keep the smoke down. This enables the occupants of the building to leave the building and firefighters to fight the fire. In basements, smoke extraction shall be ensured by 12 air changes per hour and outdoor fresh air supply by 6 air changes per hour. In the superstructure, smoke extraction shall be ensured by 12 air changes per hour. In business occupancy atriums, the air changes per hour shall be 6, and in the case of hotels and assembly occupancies, it shall be maintained at 8. All the smoke extraction fans are capable of operating at 250 degrees Celsius for a minimum of 120 minutes. The fresh air shall also be inducted into the building, which supports firefighting measures by increasing thermal drive results in the fumes being drawn more quickly through windows or openings in the roof, creating a low smoke layer along the bottom part of the room to provide a clear view of escape and rescue routes, reducing the number of explosive smoldering gases and fumes for cleaner combustion, reducing the heat, enabling firefighters to get closer to the fire. Let us summarize all that you have learned. A fire stop is a fire protection system made of various components used to seal openings and joints in the fire resistance rated wall or floor. Compartmentation is designed to increase the possibility for occupants to escape from the building. The passive fire protection system also protects the building from heat transfer from one zone to another zone of the building. Hello, welcome to this topic on smoke control and management in fire zoning. At the end of this topic, you should be able to describe the smoke control and smoke management, explain zoned smoke control, describe smoke control system activation. Smoke control systems are one of the most complicated and misunderstood systems within a facility. A smoke control system can be defined as an engineered electromechanical system that uses mechanical fans and dampers in cooperation with electronic monitoring to produce pressure differences across smoke barriers that inhibit or facilitate smoke movement. A smoke control system is used to achieve one or more of the following design objectives: inhibit smoke from entering stairwells, means of egress, areas of refuge, elevator shafts or similar areas, maintain a tenable environment in areas of refuge and egress during the minimum required evacuation time, inhibit the migration of smoke from the smoke zone, provide conditions outside the fire zone that enable emergency response personnel to conduct search and rescue operations, contribute to the protection of life and the reduction of property loss. A smoke management system can be defined as an engineered mechanical system based on its intended purpose. It uses mechanical fans, dampers, and other methods to remove smoke from a facility under post-fire conditions. A smoke management system is applied to one or more of the following intended uses: roof hatch ventilation for smoke removal in high atrium spaces, smoke exhaust fans in parking garages, pressurization fans in stairwells or elevator shafts. Let us see the design responsibilities of other disciplines in the smoke control system. Smoke management systems have a lesser degree of people involvement during design, installation, and testing. The interdependency across all professional engineering and installation trades is critical for a successful project. It all starts with the architect's building design. The facility must be designed for safety and proper egress in the event of an emergency. Once the structure, shape, size, and materials are pinned down, the mechanical, electrical, and life safety systems are designed. After that, the fire protection engineer and authority having jurisdiction, AHJ, have to ensure the following: proper engineering design, codes, contractor delivered the proper solution. Zoned smoke control systems are often arranged with each floor as a separate zone. In some cases, a floor may be split into multiple zones. These should be indicated on a graphic display either on or adjacent to the smoke control panel. Designers should not confuse smoke control system with smoke or heat venting systems. The latter are mechanical systems for the removal of smoke. They are often arranged to activate only manually. In some cases, they only remove smoke after a fire incident. With zoned smoke control, smoke movement is inhibited by dividing the building into smoke control zones, with each zone separated from the others by smoke barriers. These smoke barriers can include partitions, floors, or doors that can be closed. When a fire occurs in one of these smoke control zones, it is called a smoke zone. In the event of a fire, pressure differences and airflows produced by mechanical fans and operating dampers can be used to limit the smoke to the zone in which the fire originated. When a fire or smoke condition occurs, all the non-smoke zones that are contiguous to the smoke zone are positively pressurized and the smoke zone is negatively pressurized. The operating controls of the HVAC system shall be designed to provide the smoke control mode with highest priority over all other control modes. Normally, the smoke control sequences are activated automatically. In some cases, however, manual activation may be more appropriate. In either case, the smoke control system shall be capable of being manually overridden and manually deactivated. The automatic smoke control system shall be automatically activated in response to the signals received from a specific fire detection device or a combination of fire detection devices. Fire detection devices include automatic devices such as smoke detectors, water flow switches, and heat detectors. Generally, manual fire alarm pull stations should not be used to activate automatic smoke control systems other than stairwell pressurization systems. The reason for this is due to the likelihood that a person may signal an alarm from a station outside of the smoke zone origin. Hence, the information of the fire zone signal to the fire alarm control panel will be incorrect. This leads to inappropriate fire time action on smoke control and management system. Let us now look at the response time. The elapsed time between the instant the occupants receive an alarm or become aware of fire and their arrival at a destination where it is normally a safe location inside or outside the building. Response time is the time interval between the raising of an alarm and the completion of the evacuation. Smoke control system activation should be started immediately after receiving an activation command. A maximum transmission time of 10 seconds is allowed from the initiation of an activation signal to the time it reaches the smoke control system. The smoke control sequence should activate individual components when the smoke control command is issued. The time for fan operation is 60 seconds at the desired state and 75 seconds for the completion of the damper travel. If an individual component fails, the time lapse from the moment the component reaches its final state and the moment its associated trouble signal annunciates should not exceed 10 seconds. This means that the annunciation of the trouble signal for a fan must occur within 70 seconds of the automatic or manual activation command. The annunciation of the damper trouble signal must occur within 85 seconds of the automatic or manual activation command. Once an automatic activation has occurred, subsequent alarm signals that would normally result in the automatic actuation of a smoke control sequence. No fans or dampers should be actuated in response to any subsequent automatic alarm signal to avoid the possibility of defeating any smoke control sequence which is in progress. Let us summarize all that you have learned. A smoke management system uses mechanical fans, dampers, and other methods to remove smoke from a facility under post-fire conditions. Zoned smoke control systems are often arranged with each floor as a separate zone and should be indicated on a graphic display either on or adjacent to the smoke control panel. The automatic smoke control system shall be automatically activated in response to the signals received from a specific fire detection device or a combination of fire detection devices. Hello, welcome to this topic on case study on compartmentation. At the end of this topic, you should be able to describe the compartmentation of the floor plan of a building. Let us begin with the floor descriptions of a school building's basement. The basement of a school building houses the following areas: driveways and ramps, parking areas for cars, water pump room, electrical room, mechanical room, lifts and lift lobbies, storerooms and access staircases. The areas of each room provided by the architect are listed as below. Driveways, ramps and parking areas 1000 square meter, water pump room 80 square meter, electrical room 100 square meter, mechanical room 200 square meter, storeroom 150 square meter. In order to provide compartmentation, it is important to know the area of the floor and rooms. From the table captured from NBC 2016, car parking areas fall under the first category, that is the basement car parking area. The basement includes many other service rooms that are to be separated from the car parking areas with compartments such as fire-rated walls and doors. Let us begin with the car parking area. The NBC says that basement car parking areas shall be compartmented into areas not more than 3000 square meter. Since the car parking area is 1000 square meter, assume that compartmentation is not required in this area. However, understand that the NBC states that the areas less than or equal to 3000 square meter needs to have a minimum of 2 compartments. Therefore, the car parking area must be divided into 2. How can it be done? Using a water curtain system as a fire barrier or fire curtain with 2-hour fire resistance could drop down the fire. The other areas of the basement will be compartmented from the car parking area based on the clauses stated in NBC 2016 Part 4. Let us mark the fire rating of the walls and doors using the table. Based on the hazard, the fire resistance duration of the mechanical room, electrical room, storeroom, staircase, pump room, connecting the walls, doors, adjoining car parking area and staircase in the basement floor plan is 120 minutes. The red line indicates the compartment line of the car park area where the fire engineer could propose a fire roller curtain or a water-based fire water curtain system. Let us summarize all that you have learnt. The basement includes many other service rooms that are to be separated from the car parking areas with compartments such as fire-rated walls and doors. Based on the hazard, the fire resistance duration of the mechanical room, electrical room, staircase in the basement floor plan is derived based on the clauses stated in NBC 2016 Part 4.
Hello learners, welcome to this topic on smoke extraction in a fire compartmentation. We will now focus on the aspects of life safety, fire zoning and various systems which are adopted to bring in fire compartmentation in a building. Effective compartmentation cannot be achieved by merely installing a fire barrier and a fire compartment system. Interface with the building components and services is vital to ensure an effective system. We will learn about all these interfaces and systems in detail in this session. So let us begin. To begin this topic, we will first learn about smoke extraction and its importance in compartmentation. Smoke control is a complex process for extracting smoke and supply air through the ventilating and extracting system of buildings to ensure that people are safe to evacuate from fire. Under roof parking system, ventilation systems are developed to protect the people from dangerous smoke from the fire by extracting toxic combustion products along the evacuation routes and preventing them from spreading into the air. All the components used in a system extract smoke from a fire and transport it to a safer area such as outside. When a fire breaks out in a building, it is necessary to extract the smoke in a fire zone to evacuate people and possible victims. It is used to protect the building structure and facilitate firefighter access to fight against the fire. This also refers to any openings where smoke may be extracted or fresh air is supplied to create a pressure difference for the safe exit of the occupants inside the building. A smoke extraction system is used to extract the smoke and heat from the source to outside the building. The majority of the fatal accidents during a fire is caused by inhaling toxic gases like carbon monoxide and other gases from the combustion products. Carbon monoxide poisoning accounts for 80% of the fire accidents. During a fire accident in a closed space, oxygen supply is limited and carbon monoxide will be generated intensively. Smoke can cause loss of consciousness and cardiac standstill before a person may leave the building on fire. We will now learn about some of the most important components of a smoke extraction system. Smoke extract centrifugal fans, smoke extract jet fans. Let us now look at the centrifugal fan. The simplest form of equipment to extract smoke is the centrifugal fan. We will look at the image to know more about the components and working of a centrifugal smoke extract fan. The main components of a centrifugal fan are casing, impeller, protective grill, deflector plates and mounting brackets. These fans are further classified as wall and roof fans based on where these are installed. The jet ventilation system is the most suitable and safe ventilation solution for modern underground parking. The main components of a jet fan are an electric motor, impeller, protecting grills, guide shutters and sound insulating layer. These fans are mounted on the ceiling. The arrangement of such ventilation requires no duct work layout and thus reduce the mounting expenses by 45%. The energy losses caused by an aerodynamic resistance in the air ducts are also reduced. The jet ventilation system design requires no complicated annual cleaning of the ductworks, thus reducing the maintenance cost by 35 to 40%. To understand better, we will look at some of the smoke extraction methods for the following spaces: office building, atrium spaces and car parking area. All office buildings must be constructed to make it possible for personnel to evacuate safely in case of fire. A smoke extraction system will allow a safer exit by removing the smoke from stairwells, atriums and corridors. This system can be activated either manually or automatically by integrating with a fire alarm system. If there should arise an occurrence of fire in an office because of lightness, the hot and smoky gases will transcend the fire and spread at a significant level. The entire room will be smoke locked within minutes without a smoke and heat ventilation system. Let us look at the various methods to ventilate an office space. A natural ventilation system flows air in a structure without utilizing a mechanical framework. External air is directed through the internal space by utilizing advanced control systems. A mechanical smoke ventilation can be activated either manually or automatically. In the overall building design, fire protection and smoke extraction are vital factors. In the case of fire, the first goal is to save lives and safeguard property. Smoke sensors or smoke alarms can be directly interfaced to the smoke vent, automatically triggering its opening when smoke is detected. Smoke vents can also be manually activated by an emergency break glass point or by a fire officer with a manual override switch. Once the smoke system ventilation system is activated, the vent will remain open until all smoke has dissipated or the system has been manually reset. Mostly the smoke extraction openings are designed towards the open space. This allows the fire tender or firefighting personnel to vent the smoke and heat from the building. Similarly, the fresh air openings are also designed towards the open space. So the fire brigade can blow fresh air into the building using a mobile fan unit. This must be possible through a door or indirectly through a corridor to create the pressure difference inside the building for the occupants' safety. The shown image explains how the building with and without a smoke extraction system will behave during a fire scenario. The graph also shows how the smoke, fumes and temperature rises in the building with time. It is very clear from the image that without smoke extraction, the smoke is spreading throughout the building as the fire grows with time at a faster rate. When the fire breaks out, it is the smoke that causes the biggest danger to the people caught up in it. Without a smoke extraction system, the developments are dramatic. The first effect of smoke is impaired visions, which happen in less than 3 minutes. People lose their bearings and begin to panic. Escape routes are no longer recognizable. Then comes carbon monoxide, and concentration of this gas arise rapidly during a fire. Inhaling carbon monoxide leads to headaches, symptoms of poisoning, unconsciousness, and ultimately causing death. Openings for smoke and heat removal in large atria should be placed such that smoke and heat is removed effectively. When smoke extraction openings cannot be fitted to the roof, that required openings and opposite facades can be placed uniformly. The roof must be partitioned into smoke compartments at the roof level to restrict the smoke layer into a huge fire or smoke compartments. Shafts and smoke extraction ducts should be installed in such a way that they induce stress so that they prevent the additional spread of smoke while extracting the hot gases, fire and smoke. The most popular method to design smoke exhaust is the dynamic smoke extraction system. If it takes more time to evacuate people than to fill smoke to the safe height, or if the natural smoke exhaust system is limited because of lack of buoyancy of heated smoke and areas of smoke exhaust, we should use the dynamic smoke extraction system. During mechanical forced smoke extraction, we should also concentrate on supplying fresh air for the occupants to breathe. In contrast to other building systems, an atrium smoke control system is very hard to evaluate for design circumstances. This is mostly because of the large design fires that might damage an atrium under design circumstances. The wind is also a part of the design condition which is impossible to be judged. The atrium smoke control system must be designed perfectly to verify that it functions accurately and to check if the system components are functioning as specified. The displayed image explains the importance of having enclosed atriums. With open atriums that are naturally ventilated, the fire from the bottom most floor spreads across the floors and smoke logging happens in the upper floor, creating suffocation to the occupants. This can be addressed in either way. Having a fully enclosed atrium with the fire rated glazing allows the smoke to directly pass through the atrium and exhaust out through the openings available at the ceiling. Having a proper smoke extraction system at the top of the atrium will help in extracting the smoke from the atrium without spreading to other floors. When a fire breaks out, the smoke goes up in a plume. As the plume rises, will draw air from surrounding spaces, resulting in increase in the mass flow of the plume. The temperature of the plume decreases. As the plume hits the ceiling, it spreads out and make a layer. An atrium smoke control system will release smoke from this layer and create relatively smoke-free environment. This image shows how the smoke is extracted naturally through the atrium voids without using a smoke extraction system. The two main methods for venting fire-induced smoke in structures are natural and mechanical systems. The mechanical removal of smoke is not dependent on wind and guarantees a stable extract volume, yet high maintenance and installation costs are required. However, machine failure and power failure are inevitable. The natural smoke extraction method should be given priority. These two images show how the smoke is extracted through a smoke extraction system in the atrium roof. During a fire, the high side windows and skylights at the top of the atrium can be used for smoke extraction. However, the natural extraction system must be designed following the ambient environments because the flow field is sensitive to wind pressure and adjacent construction. Hello learners, welcome to this topic on smoke extraction in a fire compartmentation. There are two main reasons for the fire in the basement to be substantially different from fire in above ground. First, basements are enclosed with no windows or means of ventilation. Heat builds up rapidly in such conditions and therefore will not be any possible way for the smoke to escape except the stairways. Therefore, the escaping route is the only natural way of dispersal of fire. Secondly, firemen will have to descend from the grounds into the basement region, which could require them to go through the hot gas layers. Now, we would have understood the increased heat buildup is the primary concern with basement fires. The critical fire safety requirement is providing ventilation for enabling smoke and heat to pass from basement to the external. There are two main ways to reduce the amount of smoke, heat in the basement, namely natural and mechanical ventilation. In an underground car park facility, smoke is the real threat to the life of the occupants. In addition, it causes serious trouble to the firefighter in a fire scenario. Hence, the smoke extraction and ventilation design play a vital role in removing the smoke during and after the fire. Let us now look at the ventilation required for car parking, also known as closed structures. The use of complex ventilation strategies has become the general standard as every car park has its unique structural and individual criteria. Computational fluid dynamics, also known as CFD technology, is utilized to arrive at the smoke pattern inside buildings to design the smoke extraction system. Ventilation systems in car parks, loading bays and service areas are needed to achieve two objectives: day-to-day ventilation, smoke ventilation. Day-to-day ventilation is required to control the accumulation of exhaust or split fuel from vehicles. Day-to-day air quality is maintained by removing exhaust emissions generated by vehicles and ensuring that there are no stagnant air pockets. Smoke ventilation is required to release smoke from the parking lot during and after a fire. This will reduce smoke temperature and structural damage and prevent smoke from spreading between floors. Most car parks are closed or designed underground when a natural smoke ventilation is not possible. Every car park has its unique structural design, and to address this complexity in extracting the smoke, it is always better to analyze the smoke flow pattern before designing the forced ventilation in basements. To analyze the smoke flow pattern, a computational fluid dynamics study is made. Using CFD, we can simulate the flow pattern. This allows us to visualize the flow of smoke as well as heat. CFD uses numerical iterations and algorithms to solve and analyze such problems to arrive at a solution. Traditional mechanical extract system use sheet metal ductwork to transport the fumes or smoke to the external atmosphere. The duct must be evenly distributed around the car park and also dropped to a low level to provide the low level extract points. The basement extract ductwork system, as shown in the image, must be suitable for clearing fumes and smoke from the basement level. The system should normally be rated for a minimum of 1 hour of integrity and maintain at least 90% cross-sectional area. The main disadvantages of the ducted system are: basement heights will be reduced due to the ductwork that has to go below the ceiling. Protective barriers are often needed to surround low-level extract points. Initial cost and running cost for maintenance is high. Extra space is needed for the supply and exhaust fan room in the basement. We will now see the jet fan ventilation system for the basement car park. Jet fan provide the ability to ventilate and extract smoke without using any ducts, resulting in tremendous cost savings, power savings and increased installation efficiency. Jet fans can be used for normal ventilation and also for smoke extract in case of emergencies. It is equipped with supply air and exhaust air fans, jet fans and sensors. Single and dual speed fans can be controlled as well as for a single flow direction or reversible fans. Jet fans smoke control system can be installed in a broad uncluttered area such as car park and tunnels. The installation of this type of fan eliminates the need to construct the expensive hideous air input and extraction pipeline, thereby improving the visibility in car parks and increasing the availability of clearance cages. Jet fans provide an airflow that leads to the smoke to the building extraction points from the fire zone. We need control modules to assist the integration of the ventilation system with the fire alarm system and the carbon monoxide detection system. Hope you have learned about smoke extraction in fire compartmentation. Thank you. Hello learners, welcome to this topic on fire zoning. Let us learn the design of fire zoning, its importance, interfacing with other MEP services and smoke control and management system in a building. For fire, the different compartments of a building are almost separate buildings with common firewalls between the buildings. The zones shown on a fire alarm panel are linked to these fire zones. Other than small structures, all large buildings must be split into smaller detection zones. Fire can be located quickly if the detection zones are small. Building zones are decided based on the building's smoke control separations and fire control or firefighting separations. Detection zone indication must be provided even if the system is addressable type. It provides quick information of the location of the fire rather than text displays in the address, which is difficult to interpret at panic times. A simple at a glance overview of the extent of fire or smoke spread will be provided by zone indicators. Conventional detection system offers a good basic system ideal for small applications or projects that are tight for funds. Let us see the importance of fire alarm zoning inside a building. Alarm system and fire service monitoring in a building are zoned to make it easier to identify the site of a fire in the event of an emergency. Alarm systems are primarily intended to alert the building inhabitants of a fire so that they can safely exit the building. In addition, by zoning the floor area, it is easier to evacuate residents zone by zone during an emergency without much fuss. Unwanted alarms activations might occur if systems are not properly installed or maintained. As a result, resident response to actual fire alarm suffer and their effectiveness suffers greatly. The fire alarm system gets easier to maintain when the floor area is zoned. Thus, well maintained and operating alarm systems are proven life-saving devices. Because fire alarm systems are zoned, inhabitants receive warning signals and alerts quickly. This allows the building's residents to determine the exact location of the fire and flee the building. When an automatic fire alarm goes off, the local fire department is concerned about the level of chaos that arises inside the building. When the floor is zoned, this becomes much easier. This allows fire responders to predict the exact location of fire in a building without wasting time during an emergency. Let us take an example of a fire zoning layout for a floor panel before we learn about all the interface details needed in a fire zone. If the total floor area of the building is greater than 300 square meters, each zone should be restricted to a single story. If the total floor area of the building is less than 300 square meters, a zone may cover more than a single story. For voids above or below the floor area of a room, these may be included within the same zone of the room, provided that the voids and the room constitute a single fire compartment. Additional recommendations are applicable to detection zones that contain non-addressable automatic fire detectors. The floor area of a single zone should not exceed 2000 square meters. The search distance that has to be traveled by anyone responding to a fire alarm signal after entry into the zone in order for the location of the fire to be determined visually should not exceed 60 meters. Hope you have learnt about fire zoning. Thank you. Hello learners, welcome to this topic on interfacing with other services. In this topic, we will be seeing the concept of interfacing with sprinkler system, emergency lighting and public address and VA, voice alarm. The stairwell, lift well and other enclosed structure should be treated as a separate compartments or zone. A single zone's floor size should not exceed 2000 square meters unless it is a zone that consists mostly of a single open plan area such as an uncompartmentalized warehouse which should not exceed 10,000 square meters. According to Indian standards, the manual call points on each level, excluding the final exit level from the stairwell, shall be incorporated within the zone that services the neighboring accommodation on that level. The manual call point located in the stair at the final exit to open air may be considered to serve within the detection zone of the stairwell. Each input is represented by a physical zone which is created by connecting the circuit to one or more devices that serve a portion of the entire region.
Before proceeding further, let us see the video clip of how does a sprinkler system works.
There have been buildings, there have been fire accidents. The invention of fire sprinklers helped in restricting fire accidents and controlling the damage. The first automated fire sprinkler was invented by Henry S. Parmalee of New Haven, Connecticut in 1874. Until the 1940s, fire sprinklers were installed only in commercial buildings to save property. Over the years, fire sprinklers have become mandatory safety equipment in most schools, colleges, hospitals and multi-storied buildings. Fire sprinkler systems are heat activated, one sprinkler head at a time. The sprinkler head must detect a high enough temperature. Usually, there are different temperature ranges for sprinklers, starting from 57 degrees centigrade to 260 degrees centigrade, depending on the hazards. Most sprinkler heads are equipped with a glass trigger filled with a glycerin-based liquid that expands at the appropriate temperature, breaking the glass and activating the sprinkler head. The sprinkler head is attached to a system of pipes that are hidden behind the walls or ceiling. These pipes wind through the building and outside to connect with a reliable water source. When the sprinkler head is triggered, a valve to the pipe system is opened, releasing the water that is kept under pressure from the pipes. The water is quickly pushed out of the pipes through the sprinkler head, spraying water downward or upward and out to the sides. This carefully designed spray of water extinguishes the fire below or above and prevents it from spreading. Fire sprinklers use about 6 times less water than a fire hose. They are actually less harmful to your property than a visit from the fire department.
Electrical circuits connected to field equipment such as smoke or heat detectors, manual stations or sprinkler alarm switches make up the alarm start zones. The activation of field equipment gives information of fire or smoke in the particular zone of a building to the fire alarm control panel, which in turn signals to audible sounders to take required action as per the approved signaling sequence. Electrical circuits linked to sprinkler valve monitoring switches on low pressure sprinkler sensors make up the supervisory start zones. The activation of a device attached to a supervisory start zone will not cause the building's warning or alarm signals to sound, but it will generate a system monitoring problem of the system in the control unit. If sprinklers are used by the fire alarm system as a heat detection device, all of the following things must be provided with a single zone announcement in the fire alarm control unit and must indicate a supervisory problem signal in the building. Each sprinkler system has its own set of control valves. For connections to the sprinkler pipe routing, individual floors or zone control valves must be used at the sprinkler risers on each floor. If there are any leaks or cracks in the piping system, there will be a reduction of water pressure. If there is a loss of air pressure in the pressure tanks or dry pipe systems, if there are substantial fluctuations in water levels in water storage sumps used for firefighting, if the fire pump's electrical power is lost, if the low temperature in dry pipe system or firefighting water containers. All these supervision signals are sent to the fire alarm panel by using the monitor modules available. These monitor or input modules will be able to send only the signal to the fire alarm panel. Emergency lighting is lighting that is meant to automatically turn on in the case of local or general power outage. Escape routes should be eliminated to aid the safe evacuation of occupants of a building in an emergency. Emergency lighting and exit signage may be necessary under the fire safety regulations. The artificial lighting within the building is used for escape routes lighting. However, it should be supplied by a fire protected circuit. Every part of an escape route should be lit artificially by a circuit that is protected and offers a level of illumination that is not less than the suggested for emergency lighting. When artificial lighting is used to illuminate a protected zone, it should be powered by a different circuit from one that powers the rest of the escape route. A protected circuit originates at the main incoming switch or distribution board and has conductors with fire resistant insulations. Escape routes should be able to illuminated when the building is in operation, regardless of the system used. Installing self-contained emergency luminaires rather than connecting a protected circuit to the existing lighting system may be easier in conversions.
Let us now understand the concept of the escape route and open area lighting by a small video clip.
Taking place like operating theatres. But the future of emergency lighting may well be stay put lighting, where the normal use of a space can continue uninterrupted in the event of power failure. The increased efficacy of lighting and the storage capacity of batteries means that we're getting closer to being able to maintain high lighting levels for significant periods of time from battery power. Watch this space to see how that situation develops. So going back to our 3 escape route options and taking them one at a time, for an escape route up to 2 meters wide, the centre line of that escape route should be a minimum of 1 lux. Now this is a surprisingly small amount of light, roughly equivalent to the amount of light that you'll find on the ground cast by a full moon on a clear night. Along this same line down the middle of the escape route, the light level must not go above 40 times the lowest value, whatever that may be along the line. If you halve the width of the escape route and centralise it, the light level in this area must not drop below half a lux. Moving on to open area lighting, which is where we're more likely to use the lumino fitting, the rules change slightly. First of all, we exclude a band 0.5 metres around the edge of the room, then the illumination at floor level must not be below 0.5 lux. And again, we have that ratio that the brightest point on the floor mustn't be over 40 times the dimmest point.
As per the National Fire Protection Association NFPA 101 standards, the emergency lighting system installed in a building shall be tested as follows. The emergency lighting equipment, that is computer based, self-testing, self-diagnostic and battery powered, must be provided. It must be tested within a minimum duration of 30 seconds and a diagnostic routine at least once every 30 days. It must be tested annually for a minimum of 1.5 hours. It must be fully operational for the duration of the above mentioned points. The computer based system must always be able to generate a report detailing the history of tests and failures. If a building has a smoke and a heat exhaust ventilation system, the emergency lighting should be located below the smoke curtains or designed such that smoke filled reservoirs do not render it ineffective. Hello learners, welcome to this topic on interfacing with other services. Public address and voice alarm PAVA systems have grown massively in recent times. Let us take a look at what they are and how they can support the business. PAVA systems are implemented in buildings where clear, succinct spoken communications are required, either for ordinary day-to-day messaging or to safely evacuate inhabitants in the event of an emergency. In an emergency such as fire, it is critical that the people are evacuated safely and as quickly as possible. A public address system is simply a set of speakers in a particular zone that can be utilized to address the general public. Public buildings, numerous enterprises, particularly major industrial or manufacturing facilities and multi-occupancy buildings all include PAVA systems. Electronic sounders and bells are widely utilized as fire alarm warnings, but study has shown that when people are provided with a clear and easily understood message, they are less prone to panic. An instance pre-recorded statement outlining the risk and offering prompt instructions can be broadcast using a PAVA system integrated with the fire alarm system.
The aim in an emergency event such as a fire, an earthquake, or a terrorist threat is to save people's lives, thus getting the proper warnings to them at the right time is critical. Until now, emergency systems have relied on sound alarms which do not provide sufficient warning to evacuate a building quickly and effectively. They confuse people, cause panic, and waste critical seconds until people react. To overcome this issue, we will use a voice alarm system. By separating the building into various amplification zones, the system can send a live voice via the microphone or a series of pre-recorded messages to any zone or set of zones. As a result, in the event of an emergency, we can automatically alert about the situation in order to prompt a quick response. Please pay attention. There is a fire in the building. Please leave in a timely manner and do not use the elevators. Thank you. Execute a gradual evacuation in accordance with each building's evacuation plan. Evacuating the building in zones based on the dangerous proximity, suggesting the fastest and safest route to the exit, and avoiding new hazards such as catastrophic congestion. Finally, we achieve evacuations that are faster, safer, and more controlled, saving lives.
The system can also send out announcements in phases to a specific zones, allowing you to evacuate those areas that are in immediate danger first. Following that, fewer critical zones can be added. This phased evacuation planning might be important in buildings with multiple levels or complex layouts to ensure a safe escape. According to a survey, only 13% of the people respond to bells on time. People react to text information in 45% of the cases. When it comes to audio messages, 75% of the individuals respond quickly. This study shows that clear, short spoken communications are taken more seriously and arouse the desired responses from the inhabitants. PAVA systems are important in various types of emergencies as well as fire risks. A PAVA system can offer a clear, calm directions on how to respond in buildings, venues, or locations under risk of a terrorist attack. In these circumstances, just sounding a fire alarm system without the support of a voice alarm can waste the time. The PAVA system may also conduct a set of tasks during normal work hours. It can play background music, advertise announcements, passenger announcements, general paging for customers or employees, and health and safety alerts. A fire alarm system is meant to alert both on-site staff and a designated monitoring center of a potential fire event. In the case of a probable fire, smoke and heat detectors are strategically placed throughout the facility to detect fire and alert fire-rated alarm system. The system's control panel activates the flashing strobes and blaring horns throughout the building when it receives a fire alarm signal, triggering an evacuation. With a few major exceptions, a voice evacuation system works similarly to a fire alarm system. A speech evacuation system uses identical field equipment such as smoke and heat detectors, hand pulls, and so on. Instead of employing horns and strobes to notify residents of a fire, it uses speakers to do so. Pre-recorded messages can be used, or a designated individual can announce the evacuation protocols over the phone for facilities with an emergency staff on site 24/7. In addition, when emergency responders arrive, they can use the voice evacuation system to convey real-time emergency information. Given the complexity of the current fire codes, determining whether your organization needs a voice evacuation system may be out of your control. The location, timing, and method of installation of an emergency communication system are all governed by strict fire standards. All new assembly occupancies, all educational occupancies, and all high-rise occupancies must have voice evacuation system installed. In addition, the NFPA 101 Life Safety Code mandates the installation of a voice evacuation system in gathering areas with more than 300 people or theatres with more than one audience viewing room. In a nutshell, some firms, particularly large ones, are obliged by law to install a functional voice evacuation system before they can open. Given the advantages of emergency communication system over traditional fire alarm systems, many smaller firms have made the switch. When building occupants hear a voice alerting them to a real emergency, they are less likely to believe it is a drill. The ability to pre-record messages for various circumstances on mass notification systems provide far more efficient emergency procedures that go beyond evacuation. Many of the existing components of modern fire alarm system can be used to convert a traditional fire alarm system to a voice evacuation system. I hope you have learned interesting things about interfacing systems in a building. Thank you. Hello learners, welcome to this topic on fire compartment components part 1. In this topic, we will see the fire-rated door, wall, and curtain. The spread of fire can be restricted by subdividing buildings into several discrete compartments. These fire compartments are separated from one another by compartment walls and compartment floors made of a fire-resisting construction which hinders the spread of fire. The degree of subdivision that should be provided by a fire compartmentation will be dependent on the use of the building, the fire load in the building, the height of the building, the availability of a sprinkler system. So, architects, designers, insurers, and contractors must construct buildings that are safe in the event of a fire. Good quality products can be severely compromised by poor installation compartmentation systems. Let us now look at the fire-rated wall or floor. Fire-resistant flooring and wall systems reduce the spread of flames and smoke in the event of a fire-related incident within a facility. A fire-rated wall extends through the roof between the slides of a building. It also extends downward through the floor. In such a way, it is designed and certified to prevent fire from spreading through a building in the event of fire ignites on one side. Firewalls thoroughly separate sides of buildings and provide stable structural support. A fire barrier wall or fire partition helps to contain the fire and prevent it from spreading, but it does not provide structural support, nor does it extend through the roof line and floor. Additional measures may be needed in a building where an atrium, chute, stair, lift and so on pass through a compartment floor. A fire door is a door with a fire resistant rating used as a part of a passive fire protection system to reduce the spread of fire and smoke between separate compartments of a structure. This enables safe egress from a building or structure. Fire doors serve three main purposes. They are to maintain the integrity of means of escape in the event of a fire, to isolate areas within a building that represent a significant fire risk, to provide access through compartment walls. The fire door is a combination of a frame, hardware and other accessories that together provide a specific fire resistant rating to the opening in terms of its stability, integrity and insulation properties when installed in the openings in fire separation walls. Around the edges of the door will have the intumescent seal, which is designed to expand when a specified temperature is reached. It seals the gap between the floors and frame. A fire door is a component of the fire door assembly. To prevent the spread of fire from one zone to another through the penetrations used for electrical and mechanical services, fire stopping sealants are used, and these fire stopping products shall have the specified fire rating as the compartment wall and floors. A fire stop or fire stopping is a form of passive fire protection that is used to seal around the openings and between joints in a fire resistant wall on floor assembly. The passive fire protection industry have devised many solutions to deal with this, including fire dampers, fire resistant mortars, pipe wraps, collars and fire resistant gap fillers and sealants, collectively known as fire stopping products and systems. Fire stops should not be confused with cavity barriers that are intended to block routes for smoke and flames spread through concealed spaces, such as those that may be found in walls, floors, ceilings and roofs where concealed spread can present a significant danger. Fire curtains and smoke curtains are active fire barrier assemblies that comprise technologically advanced fire resistant fabric encased in a compact steel housing. They remain invisible, retracted until activated by an alarm or detector signal, at which time the fire barrier assemblies descend safely to their fire operational position. To be compliant, this type of fire barrier using a fire curtain or smoke curtain must be protected from a short circuit or total power failure, which is achieved with the help of a total gravity fail-safe system. But to deploy fire or smoke curtain, it is triggered by a fire alarm system. Fire curtains and smoke curtains stop the spread of fire and smoke in a building when retracted and offer large free open spaces in normal conditions. This fire barrier allows the evacuation of occupants or rescue personnel with emergency retract buttons. The unique overlapping design can provide unlimited width for large areas. Before getting into the details of fire and smoke curtains, let us see the components of the fire and smoke curtain system in detail. Head box. The steel head box houses the roller, fabric and motor within the casing, creating a small compact package that remains virtually invisible above the ceiling. Roller, barrel and tubular motor. A tubular motor drives a steel roller tube to retract and deploy the fabric from its normal position in the head box to its operational position. Guide rails. During deployment, slim steel slide guides prevent derailment of the fabric during operation. It ensures the integrity of the system when faced with the positive or negative pressures of a real fire. Fabric curtain. Woven fiberglass wire reinforced fabric with individual panels stitched and hemmed using stainless steel thread. Steel bottom rail. The bottom bar provides weight and stability to the system, ensuring a gravity fail-safe deployment. A fire curtain is similar to a metal roller shutter in that it descends vertically as it unrolls from a top box. However, because a fire curtain is made of a woven reinforced fiberglass material, it is much more flexible and compact. The compact construction of a fire curtain makes them an ideal choice for lobbies, hatches and stairwells. There are several types of fire curtains. Automatic fire curtains. Most non-static fire curtains are automatic. They are linked to the fire alarm system, so they automatically descend when there is a fire. Static fire curtains, also called fixed fire curtains, these curtains are permanently in place. They are used to provide compartmentation in open spaces such as warehouses or lofts. Insulated fire curtains. These curtains provide extra insulation and allow people to pass by much closer to the curtain without being affected by the heat of the fire on the other side. Now you have a clear idea about the fire compartment components used in the building. Thank you. Hello learners, welcome to this topic on fire compartment components part 2. International Building Code or IBC defines a smoke barrier as a continuous membrane either vertical or horizontal such as a wall, floor or ceiling assembly that is designed and constructed to restrict the movement of smoke. Section 3.3.31.2 of the National Fire Protection Association or NFPA 101 says a continuous membrane or a membrane with discontinuities created by protected openings where such membrane is designed and constructed to restrict the movement of smoke. The purpose of a smoke barrier is to prevent smoke from penetrating and moving within a concealed space in a fire compartment. These barriers are mostly used above the false ceiling levels. If a barrier in a concealed space coincides with the compartment wall or floor, it shall normally be required to provide the same fire performance as the wall or floor. Fixed smoke ports are widely used in the voids above the false ceiling to avoid the spread of smoke from one occupancy or compartment to another. Smoke curtains are a barrier placed as part of a smoke management systems in a building. It is used to channelize the movement of smoke in a building towards extraction points. Smoke curtains are highly effective at protecting occupants from smoke inhalation and heat damage to the building itself. As discussed earlier, smoke curtain comprises of roller with motor and bearings, fabric rolled around the roller or the barrel, steel bottom bar fixed at the bottom to guide the curtain while dropping down. Head box contains the motor which is interfaced with the fire alarm system to trigger the smoke curtain to drop during a fire scenario. In the case of a lengthier compartment wall, multiple smoke compartment curtains can be overlapped for effective compartmentation. Usually each compartment or zone shall be integrated with the zone control panel. This control panel shall be programmed to decide which curtain should drop in case of a fire. Battery backup for this curtain system is mandated in general. Fire and smoke curtains must be rigorously tested and certified. These standards ensure that the integrity of a curtain will remain for a minimum length of a time and that is will continue to work in case of the extreme conditions of a fire. Smoke curtains shall comply with certain standards set. It can be British standard, Underwriters Laboratory, American National Standard Institute or a factory mutual. These testing shall include exposure to heat for a minimum temperature of 600 degrees Celsius. To test the reliability of the motor, these shall be operated up to 1000 cycles. Test also includes checking the response time of the smoke curtain begins to drop from the ceiling to the required level of drop. The speed of the descent of the curtain shall fall in between 0.06 meter per second to 0.3 meter per second. Generally, gravity descent of the curtain is widely preferred. At times, in worse situations, power descent can be permitted. There are 4 main styles of smoke curtains that will be compatible with other fire safety systems. They are elevator, vertical draft and perimeter. Elevator smoke curtain. They perform the vital function of blocking smoke from entering and exiting through elevator doors. Elevator shafts cause air to be extracted upwards through to the roof of the building. In case of fire, this can make the smoke spread quickly to other floors of the building. Vertical smoke curtain. It is used to close off openings from standard doorways to large open roofs. They can be located within the ceiling above the opening and are deployed downwards to prevent smoke from spreading through the building. Draft curtain. It is a type of static curtain that is most often placed in expansive and open facilities with high ceilings. Example, warehouses and manufacturing environments. Perimeter curtain. It is an ideal solution for containing smoke in a building with large open staircases or escalators. They function similar to vertical curtains, but instead of blocking off one entryway, they form an independent perimeter requiring no walls or corner posts to be present. It is designed specifically to slow flames, and it will help to slow the movement of the smoke as well. In today's modern world, where open space design is often integral to the functioning of many buildings, designers and architects face real challenges trying to reconcile open plan designs with fire safety regulations. This is because open plan designs involve a removal of fire barrier, leaving the building open to fire damage. Fire curtains in these buildings are proving to be a perfect solution. They allow for aesthetics, safety and functionality to all coexist. It also helps in avoiding conventional barriers like a wall, door or shutters and so on. The fire curtain shall be always automatic in operation. That makes the fire curtain part of an active fire protection system. Automatic curtains usually use a similar fabric as the smoke curtain, but wire reinforced to withstand higher temperatures, wrapped around a motorized roller. Side guide rails are always required in a fire curtain, since the curtain must seal or compartment fire 100%. A fire curtain is a barrier placed in a building where there are fire compartmentation cannot be achieved through conventional systems like a fire rated wall, door or shutter and so on. As discussed earlier, the fire curtain also comprises of roller with integrated motor and bearings, fabric rolled around the roller or the barrel, steel bottom bar fixed at the bottom to guide the curtain while dropping down with side guide rails. Head box contains the motor which is interfaced with the fire alarm system to trigger the fire curtain to drop during a fire scenario. In the case of a lengthier compartment wall, multiple fire curtains can be overlapped for an effective compartmentation. Usually each compartment or zone shall be integrated with the zone control panel. This control panel shall be programmed to decide which curtain should drop in case of a fire. Battery backup for this curtain system is mandated in general. The major differences in the construction between a smoke curtain and fire curtain is the motor shall have a heavy torque since the fabric is woven with wire reinforcement. Now that we have learned about the fire curtain and smoke curtain, let us see the differences between the smoke curtain and the fire curtain. As a part of smoke control system, a smoke curtain is used. Its purpose is to either prevent smoke from reaching from another zone or to channel it through a certain path. A fire curtain, on the other hand, is used to distinguish two places in the event of a fire. It may control smoke, but its primary goal is to prevent the spread of fire. It is commonly utilized to shield an open stairwell or to keep the fire from spreading from one level to the next through an open atrium. A smoke curtain is only designed to be exposed to a smoke since it has a fire rating of 600 degrees Celsius. A fire curtain, on the other hand, may be exposed to the flames and the fire temperatures can be much greater. So, the curtain must be more durable. The fire curtain has been tested against the standard ISO fire curve, which has a temperature of more than 1000 degrees Celsius. If you try to use a smoke curtain in a situation that calls for a fire curtain, the smoke curtain will not be able to survive the fire temperatures. Smoke curtains do not go all the way down to the ground, ceiling to the floor. They are usually placed above the head height to avoid interfering with escape routes. The fire curtain, on the other hand, should descend to the floor level and ensure complete fire compartmentation. Similar to a smoke curtain, testing procedure for fire curtains shall also comply with certain standards set. These testing shall include exposure to heat for a minimum temperature of 1100 degrees Celsius. To test the reliability of the motor, these shall be operated up to 1000 cycles. Tests also include checking the response time of the smoke curtain begins to drop down from the ceiling to the ground level. The speed of the descent of the curtain shall fall in between 0.06 meter per second to 0.15 meter per second or 0.3 meter per second. Apart from the above test, a 100% sealing test was also carried out to check if the heat is getting radiated or passed through the curtain system to ensure the compartmentation requirement.
The smoke and fire curtain will be tested in the same way. The only difference in testing fire and smoke curtain will be the temperature. Let us now look at the real-time testing of a fire curtain in a testing laboratory.
Let us see the application of the fire curtain. Traditionally, a protected means of escape would be along with the brick or concrete corridor. However, it may be that the building design does not lend itself to permanent and structural barriers. Fire curtain offers a sealed curtain for the immediate face of any elevator door. This may not suit the building fire strategy. There may be a requirement to create a protected lobby in front of a bank of elevator doors. Fire doors are a necessary but cumbersome item. They are required in many situations, however, they are by nature heavy and restrictive for movement. They are difficult for small children, the elderly, or the disabled to open. Smoke compartments are formed to prevent smoke from spreading throughout a building. They must be impermeable to smoke leakages within set criteria, but also offers a level of resistance to heat. Protection must be provided to the rapid buildup in heat caused by hot smoke hitting the barrier, a scenario in which some type of glasses will shatter. Fire curtains provide excellent level of smoke containment as well as high heat resistance. Although the smoke and fire curtains can be easily retracted to allow for quick evacuation during an emergency, there is always the need to develop new ways of save time and eliminate delays. Using a fire curtain allows for an even quicker emergency evacuation pathway for occupants. Escalators and stairs, both items create a permanent breach in the compartment between floors. Using smoke and fire curtains can be tackled in several ways depending on the strategy requirements. There is the option of using smoke curtains around the lower level to create a deeper reservoir depths, or full-fledged fire curtains to seal off the escalator or stairwell completely.
Let us look at the real-time video of the internal staircase fire compartmentation.
Forming fire compartments require a curtain to have good level of integrity. Protective curtains installed to form a compartment must be able to provide a physical barrier to the fire and prevent heat flux transfer of levels sufficient to ignite materials on either side of the compartment. Fire curtains provide the highest level of protection certified for use around the world. We have completed this topic. I hope you have learned about fire compartment components. Thank you. Hello learners, welcome to this topic on water curtain systems. In this topic, we will see the configuration and importance of water curtain system. The water curtain system is one of the active fire suppression systems. An active fire suppression system means it becomes active only when there is a fire. As the name itself defines, it forms a curtain to prevent the spread of smoke, heat, flame from a fire captured area to a no fire area. The water curtain system constitutes a separate pumping system and a set of nozzles that are mounted radially to diffuse water at high pressure during fire accidents in basements. This system prevents the spread of fire across the basement compartments. The compartment may vary based on the basement profile. Water curtain systems constitute a set of nozzles that are mounted radially to diffuse water at high pressures during fire accidents. This system is the most effective at preventing the spread of fire across walls, windows and ceilings, thereby preventing all unwanted damages to the space. Generally, a water curtain system is used in the basement car park to contain the fire within the compartment area. The discharge and distribution of the water are uniform in the high velocity water curtain system and are the prime reason for avoiding the water curtain system inside a building. As the high discharge of water might ruin the properties and damage the expensive electrical equipment, also draining that huge volume of water would be a tedious process inside a building, whereas in basements it becomes much easier by just providing a small slope on the floor to drain the water to the drain pit. The system will encapsulate the fire between the water curtain sections to allow the evacuation of people who may be trapped inside the basement. Basement car parking does nothing but store cars. Hence, instead of utilizing the expensive fire curtain system, a water curtain is utilized. In basements specifically used for car parking, where we cannot have conventional compartmentation like walls, doors or shutters, for that a water curtain system would be an ideal solution to compartmentalize the basements. We will understand the components and working principles of the system in brief. Compartmentation means providing a barrier to a large area so that fire, heat, smoke cannot propagate. The barrier can be a fire-rated wall or fire curtains or water curtain. The water curtain system consists of a reserved water, dedicated pump, valves, isolation valve, non-detent valve, deluge valve, etc., pipes, fittings, water curtain nozzles, fire detection devices and so on. The system consists of water curtain nozzles that will create a homogeneous water spray with high velocity and medium to small size droplets. Nozzles are connected to the piping system designed to cover the cross-section area of the basement. Each water curtain compartment or zone is provided with an electric hydraulic operated deluge valve that will open upon a signal from the fire detection or a manual remote controlled operating system. Let us look at the typical car parking area and how a water curtain system is used to compartment it. As we know, basements that are used for car parking shall be compartmented using a water system. The compartmentation or zoning shall be done strategically. Zoning shall utilize the civil structures to their maximum extent to avoid the increase in number of nozzles. If the number of nozzles in the compartment increases, the demand for water and flow of water will also increase. That subsequently increase the size of the water storing sump, which results in increase of civil cost for the construction of a bigger sump. To achieve the demand for water and flow, a higher sized pump has to be proposed, again resulting to increasing the cost of installing a higher capacity pump. To accommodate the higher sized pump, the pump room size has to be increased, which increases the built up area of construction. As a contractor and end user, it is very much important to cleverly design the water curtain system. The addressable heat detectors at the basement ceiling level will detect heat and transmit the signal to the fire alarm panel in the event of a fire. Then the fire alarm panel shall send the signal to the solenoid valve of deluge valve of the respective zone. The deluge valve gets activated and water will be sprayed through the water curtain nozzles. The system can also be activated by pressing the manual push button and emergency release valve. The discharge and distribution of water are uniform in high velocity water curtain system or otherwise known as sprayers. These nozzles are usually connected to water, air or pressurized nitrogen sources through which a deluge valve is opened, which fire detection system raises an alarm. Nozzles are usually mounted in the horizontal position facing opposite to the ground, and these nozzles, which are used in high velocity water spray systems, are also called projectors. The water curtain pump is connected to the water curtain nozzle through a deluge valve. From pump to deluge valve, the pipelines are normally flooded. Flooded here means the pipeline contains pressurized water. From deluge valve to water curtain nozzles, the pipelines are dry. When the fire or smoke is detected in one compartment, the corresponding fire detection device or through the sprinkler flow switch located in the premises will send a signal to the deluge valve to open and subsequently will switch on the pump. Water will be gushing into the water curtain system and reach those nozzles. These nozzles have special properties of forming a curtain from water preventing smoke, flame, fire, heat to propagate. Spray nozzles are chosen based on many variables, the most important of which is their capacity to disperse water in such a way that the right mechanism of extinguishment or control for the danger may be achieved. Spray nozzles come in a variety of sizes, capacities and orientations. The design employed inside the spray nozzle to manage the flow of water through the spray nozzle will influence the water droplet discharge velocity and the reach or range of the discharge pattern. Fixed nozzles are only effective within a particular velocity or pressure ranges. The discharge pattern is inefficient below the lower pressure limit. Beyond the upper limit, velocities may be obtained that result in decreased efficacy owing to reduced discharge pattern, delivery distance and or water droplets. Spray nozzles come in a variety of spray angles. The actual velocity of the water droplets and the range of the spray will be determined by the volume of water emitted and the spray angle of the nozzle. Spray pattern profiles are given in the graph for discharge pressure from 1.4 to 3.5 kg per square centimeter. When discharge pressure above this is applied, then the coverage area will decrease because the spray pattern tends to draw inward at higher pressures. Let us see an example calculation for the nozzle having K factor 23. The effective working pressure of the system is 1.4 bar to 3.5 bar. The maximum spacing allowed between two water curtain nozzles is 2.5 meters. While calculating the water demand, it shall be done for the maximum sized compartment or in the compartment where a maximum number of nozzles are used. Let us assume 75 nozzles are required to ensure compartmentation in a basement zone. As we all know, the volume of water required can be calculated by multiplying the discharge coefficient and square root of the average pressure required for operating the remotest water curtain nozzle. When the volume of water calculated is multiplied by the actual number of nozzles, we can arrive at the actual volume of water required to discharge in that compartment per minute, which is 2700 liters per minute. Compartmentation using a water curtain system shall operate for a minimum of 60 minutes. Hence, multiplying by 60 with the calculated discharge volume gives the exact water demand exclusively for the water curtain system. Based on this result, the storage sump size can be designed by the structural design team. Before we wrap up with our learning on water curtain system, let us list down the advantages and drawbacks of the water curtain system. The advantages of water curtain system are: water being a natural resource, it becomes the most reliable system. During the evacuation of the occupancies, the water curtain system does not hinder the people movement. Since the water curtain meets the compartment zone, it prevents the flame from passing from one zone to another. This means that the flame spread would not be possible without another flame source in other zones. Maintenance of the water curtain system is much easier. Annual maintenance of the pump is more than sufficient. The disadvantages of the water curtain system are wasting away the available water resource. Since the pipes are not flooded with water, after the deluge valve and the nozzle is open, the moisture in the air can slowly start corroding the pipes. This could result in high cost while replacing the pipe network. If large ducts or cable tray crosses the zoning line, the water curtain nozzle cannot wet the area below the service passage, and this void could let the smoke or flame pass to the next compartment easily. This will result in the activation of the water curtain system in the next zone, creating more demand for water. Hope you have learned more things about water curtain system. Thank you.